dan drugi, ali ste live stream na vašem kanalu, samo pišite day 2.
Okay. Welcome everyone. Dobrodošli. Welcome everyone to day 2 of Descon talks and pondering about minimum data sets. We're trying to tease out this concept, how it works, what it means, and well, it seems to mean many different things to many different people. But really there are some need to discuss this in terms of what is the minimum data I need to have to carry out my purpose, whatever that is in that context. So let's just quickly go through the agenda. Today, I think we're going to have a fantastic day when we see who's speaking today. We will have a live stream as well that we appreciate if you can share also online with your networks. We are happy to be here in rainy Belgrade, and again this year in Impact Hub. So we'll have to have a great program today. So a little bit more about that is that we'll start with a series of talks and series of workshops and the hackathon that has started yesterday. We have two types of hackathons. One is about enhancing Klimerko's feature, which is something that was born out of Descon. It's an air monitoring system for the ambient air that citizens can install themselves outside of their windows, garage, or balconies. And it's the fastest growing network in the southeastern Europe. We will also have a workshop at 12 starting how to assemble it. You can join the workshop and get your own monitoring device to take home with you. Also, we will have another workshop about manifesto and the capture, what is minimum data sets, the formats of it. We have a very nice fanzine about artificial intelligence created by Larissa, and you're free to join that workshop as well, but I won't say much, just to tease, send a teaser so that you find out more yourself. So very happy to see everyone. We'll have the first speaker will be Christo, who I'll introduce briefly, and then we have a fantastic lecture by Vladan Joler on the genealogy of power and technology. The last 15 years, the workshop I already announced, it's taking place downstairs to the left. We will then hear from Jari Arkko about the impact of networking on the environment. He's a top expert at senior expert at Ericsson and an internet geek, previous chair of the Internet Engineering Task Force, and previous Descon attendant. Edmon Chung will be remote as well. He is working on a very exciting project about eco-friendliness of internet infrastructure and data governance. I'm part of his advisory board, and I really do think that you should listen to his talk as well. The other part of the hackathon that we have is, and the workshop is this enhancing the UX for the Copernicus satellite data. We have been asked to set up this workshop because people are trying to use this data and it's very clunky and the user interface is not as nice. So let's see if we can come up with the ways how to get this data. And then there will be lunch served downstairs, and we'll, after lunch, hear from Hack Club member Petar Simovic. He will be talking about Internet of Things and security aspects and using some open source tools to protect the Internet of Things. And then we'll have a short break following by a panel. And this panel will be looking at how to empower citizens with technology know-how, how to get involved with citizen science, what could be done, especially focusing on air pollution in our, but be here and ask the questions. We'll have a fantastic set of experts and climatologists talking about that. The one I skipped was the presentation about digital climate atlas of Serbia that has used Copernicus data already, so we can see how they have used their data, what we could reuse or relearn from them, and combine our findings. After the panel, there will be a workshop led by Larissa and Brona, who you heard yesterday, about the minimum data set manifesto, taking in some points that we discussed yesterday in our panel. Who's the curator and what are we curating? Is it the machines or is it is it humans? So all these challenges that are combined with this idea of whatever the minimum data set could mean. Finally, we will have the presentation of the hackathon. The teams will present either Capture the Flag or Enhancing America or the Hardware Hackathon. And after the presentation, we'll be having some fun with Sergio Music Lounge, and he's a really, really good musician, I recommend, and we'll have some beats, and we'll leave here around 8. So I hope this will make it a little bit fun for you today to, dip in all these different areas. And we'd just like to thank our sponsors for the event. Of course, it's a community, mainly technical and art community event. We don't have any sponsors or industry representatives here. They have the Internet Society Foundation, thank you, the .me registry, the .rs registry, and the RIPE NCC, as well as the Hack Club members and the Internet Society chapter. With that, I would like to invite our keynote and next speaker, Christo Buschek, to come and join us, because maybe I should say couple of things about Christo's work, who I've met many years ago. The presentation will show up now. He's, among other things, being a data journalist and being a programmer and data journalist, which is this new combo that we're seeing in new titles appearing. Is a Pulitzer Prize winner, and he's a software developer, but we have decided that he doesn't speak about that work today, but something more exciting that he's been working on recently. So without going further into that, I'd like to thank you all for being here today and invite Christo to take the floor. Christo, the floor is yours.
Well, thanks a lot. Thanks a lot for coming on the Saturday morning. Thanks. I love to be in Belgrade. I'm coming here now for, I think, almost 10 years. I'm regularly nearly every year in Belgrade. I have a lot of friends here. I feel like Belgrade is like one home for me, definitely. And I want to thank to Des and to Jana for setting up this Descon. It's my 3rd Descon. Maybe it's my 4th. We are not sure. We couldn't put it together yesterday. But I think it's great that this event exists and that I'm able to be regularly a part of it. And so I think we should give an applause to Des and Jana for putting this up, because it's a lot of work to set up a conference like this. My name is Christo, and I work as an investigative journalist at Der Spiegel and Paper Trail Media, and I have a few other hats as well. I used to be a programmer. My background is actually human rights investigations, but now I feel like I can apply this technology or this technique, the method of investigation, to a lot of different fields. So we can apply this like in academia, we can apply it in human rights, we can apply it in journalism, we can apply it in a lot of fields. It's a way of thinking. So I want to talk about this investigation that I published this spring, I think it was March. And interesting enough, like it was around a year ago that I was in Belgrade presenting for the first time the idea of this investigation at a conference at the university here. And back then it was like a little bit of a workshop and we didn't know what it's going to be. And we just had like a few Excel spreadsheets to show. And now basically like this is the result of this work. So we all know, like for years we've been bombarded with news about AI. And these systems, they're investments that are going into the trillions and they're deployed with like a neck break speed. And this level of hype doesn't seem to be ending. It keeps on going. And the bad thing is that like until recently, the discourse on AI only took the form of either, oh no, we're all doomed, Terminators will walk the streets, or only with AI we can cure cancer. But the interesting thing is that behind both of those narratives, we find the same people, we find the same companies, and we find the same interests. I don't know about you, but like I feel certainly that I'm being treated with a stick and a carrot here. So to be clear, I think the fault lies with us, like with us journalists specifically. For a long time, we did a very, very lousy job reporting on AI. We were dazzled by AI. I think it's important we look at AI from an investigative standpoint, and we should hold it and the interest behind it accountable for what they're doing. But I think we are getting better, we journalists. If you track the discourse on AI, you will notice that something changed in the last weeks and in the last month. We slowly realized that the Sam Altmans of the world were overselling AI. They hyped it up so much that the only problem they could ever imagine was that AI might kill us. But the real problem, it turns out, is that AI can barely answer a question accurately. AI is unreliable and it's repeatedly wrong. So the real threat here, in my opinion, is not that AI is smarter than us, but it is that we think it is smarter than it actually is. So technology does not evolve in isolation. It is made. It contains values. It is the result of choices. We often hear that technology is neutral and it only matters how you hold it, how you wield it, and it can be used for good or bad. But I think this is utter nonsense. It is really crap. Technology is a tool, and our tools shape us, and thereafter, no, we shape our tools, and thereafter our tools shape us. So in this talk, I want to propose dataset investigation as a tool, as a method for holistically interrogating AI. The data, the models, and also the effects of AI. Because when we look at these, if you look close at the data sets that are used to train these incredibly complex machines, we actually recognize the models that are powered by them, and we learn about the emerging effects of these systems. Since we don't understand how models work, and actually no one really does, it is only by looking at the data sets that we get a better sense of how AI models work, and the gaps, and the errors, and the biases that can emerge. Not working? Some small technical differences. Few performance issues here. So I want you to introduce you to a mystery woman. So I don't know who she is, and I don't know her name. I don't know how old she is, and I don't know where she's from, what she studied, or what she wanted to become when she was little. What were her dreams? What are her sorrows? Her image is one of 5.8 billion images that are used to train machines how to interpret the world. These are a lot of images. If your full-time job would be to look 5 days a week, 8 hours a week, at each image just for 1 second, you would be working for 780 years. This image is part of Lion 5B, an open source data set of images and text captions scraped from the internet. It is designed for large generative models and was released in 2022 by Lion, a German non-profit organization. We usually think of Lion 5B as like one singular entity, just one gigantic training data set. However, it consists of 3 separate parts. So on the one hand, we have Lion 2B EN, So that's 2.3 billion image text pairs where the text was algorithmically identified as English. Then we have line 2B multi, 2.26 billion image text pairs, where the text was algorithmically identified as any language other than English. And then we have line 1B no lang, 1.27 billion image text pairs, where the language couldn't be detected by the algorithm or the confidence level was too low. Training a model on line 5B is meant to give a comprehensive representation of the world and build a vocabulary of things and concepts. The goal of the project to create line 5B was to conduct basic research into dataset curation, but specifically its authors wanted to create an image training set with purely automated methods, with no humans in the mix. The resulting hands-off dataset has been used in hundreds of academic projects. And the paper presenting line 5B has been referenced over 1,300 times in academia. Here we have some examples of what is contained in this dataset. Each entry of the 5.8 billion images look basically like this. On their homepage, the creators of line 5B explicitly warn against using line 5B in real-world contexts. This warning has been largely ignored. Midjourney and Stable Diffusion are two large models, known models, both are trained on line 5B. It is likely, and when I say likely, I mean really, really, really likely, that many other commercial models, perhaps hundreds of them, have been trained on the dataset. Models that power chatbots and generative image generators. Models that touch the lives of millions of people. So how do you tackle a thing that is far too large to comprehend? How do you investigate something that takes lifetimes to look at? You start by trying to understand exactly how it was made. You go back to the moment of its creation. Line 5B was not created out of thin air. It itself was built from an even larger data set called the Common Crawl. Every month, a non-profit with the same name crawls the internet and compiles every web page that it sees. Every month, it publishes a data set of this crawl, and it contains every month around 3 billion website pages. This is how a website normally looks like. It is just a file containing text, and it describes how it should look like. When you use a browser and you browse to this website, it describes like how it should look like. We won't discuss the details of the Common Crawl here, but I think the Common Crawl would be worth an investigation itself as well. But we are very interested in this here. I hope you can all see it. It's like, this is what like line 5B takes from the Common Crawl. It takes the Common Crawl and it looks for these image tags. Lion devised the process for selecting images from these websites. So on the surface, this sounds very, very harmless and obvious, but the details do matter here. From this large corpus of billions of websites, we can notice that some of these websites are particularly well represented in line 5B. There are nearly 155 million image and text pairs that are coming from Pinterest, about 1 in every 40 pairs of the data set. We have 2.4% of line 5B, 140 million image and text pairs, comes from Shopify.com, and an online e-commerce platform. This number is even higher, 5.8%, if we only look at the English subset of line 5B. And we have 72 million pairs that are coming from Slide Player, a platform for storing and sharing PowerPoint presentations. So one reason why these websites are very well represented in line 5B, because obviously they contain a lot of images. But on top of this, these websites, the content from these three websites are served up in a way that makes it particularly appealing to Lion's method of statistical curation. So as we said before, Lion extracts these image tags. So let's take a look, what is an image tag? So it is a little piece of code that tells the browser what images to show in your browser. There are two interesting elements for us in an image text. On the one hand, we can identify an image source, a link to the file, the image itself, and we can see the alt tag, which is an image caption. A little bit off, but like identify the two parts. To make Lion 5b, the developers of Lion processed the common crawl looking for these HTML image tags that contain an alt attribute. This alt attribute, the image caption, the purpose of it is actually to improve accessibility on the web. It's particularly meant for vision impaired users who are relying on screen readers to browse the web. You are not forced to set an alt tag when you program a website. You should, but most people actually don't. It's only under 40% of all images on the internet actually contain such an alternative description and an image caption. These are examples from Pinterest. Pinterest generates the captions on its websites from the alt tags of the images. So users of Pinterest learn to write alt text before they pin the Pinterest images. Shopify users often have the eye on high Google PageRank results. So they write alt tags in a way so that like search engine optimization takes place and they get like a high ranking on the Google search. And Slide Player, for example, seems to add alt text with the text from each slide for every slide. So they do this automatically. So let me come back to this image of the mystery human. If I ask you now what you would see, I'm pretty sure you would all say like, I see a woman. And this is what a machine is taught about this image. And immediately we notice a glaring omission here. We can see that alt tags do not necessarily represent what the image is about, but are an artifact of the web's inner workings and the retailer's ambition. So this image is taken from a Shopify.com website. So alt tags should describe what the image is about. However, most tags often describe what the site's owners want algorithms to see about the image, not what they want humans to see about the image. And here we can find already the first important insight about like Lion 5b. It contains less about like how humans see the world than it does how search engines see the world. It is a data set that is powerfully shaped by the commercial logic of today's web. Let's dive even deeper into this construction of Lion 5b. From the source corpus of the common crawl, Lion extracted over 50 billion images that were candidate images. From those 50 billion images, they selected only 5.8 billion. So how did they do that? So a key part of Lion 5b's construction was to try to select images from the common crawl where the text caption and the image are similar, where they closely match the content. To do this, Lion developers used a machine learning model called CLIP. It is a neural network developed by the researchers at OpenAI. The developers used CLIP to get a score of how well a string of text matches an image. It is a metric for the similarity between a text and an image. So this is the tricky part. So I repeat it one more time. CLIP is a machine learning model that claims to calculate a similarity between text and an image. Lion 5b's author used this score to determine which images and captions from the common crawl, from these 50 billion candidate images, would end up in the data set of only 5.8 billion. They calculated for every image and caption a score, and this score can be between 0 and 1. To arrive at the minimum acceptable score, like what is the minimum threshold of like how well does an image and the caption have to match, they trained their own model with samples from their own data set and then ran this model and compared it to benchmarks such as ImageNet 1K. And this is what we call the similarity threshold. It is the minimum CLIP score, the minimum similarity between an image and its caption to be added to the data set. They determined, with no reasoning, just they said this is the score, they determined that image text pairs with a similarity score of between 0.26 and 0.28, depending on the language of the caption, would be included in Lion. This single threshold, this single score, the supposed similarity between text and image, is the one thing more than anything else, that defines which images line 5B contains and which are not. CLIP, like most neural networks, is difficult to reverse engineer. OpenAI is not forthcoming about the data set that they use to train CLIP. The image pairs in Lion and their scores give us a glimpse of like how CLIP is actually working. By looking at the images at the extreme edges of line 5B's similarity thresholds, we can get a sense of how CLIP perceives images and how the use of this score might influence what Lion includes and what it excludes. The CLIP scores that the Lion team generated seems to have an upward bounce in the 0.5 range. Only 22,654 images of the entire 5.8 billion data set score higher than 0.5. We can also see that pretty much anything about 0.45 is mostly pairs where the images contain exactly the same text as the caption. So it is an image that says hello and the caption says hello. We only verified this for the range of above 0.45, but like from looking at these images, I'm pretty sure this is true for the whole 0.4 similarity score range. If you look across line 5B, it's clear that these CLIP scores are very unequally distributed in the data set. Very often the scores are near or like exactly the threshold that the line shows as a minimum similarity threshold. Here we see the distribution of images in the multi-language data set. A full 16% of the total images across all of line 5B have scores within the 0.01 similarity range on the lowest bound. This number is even higher for the multi-language subset, where we have 25% of the whole data set being exactly having a similarity threshold of 0.26. This means that if the Lion developers would have raised the CLIP similarity threshold, the minimum threshold, just by 0.01, they would have removed almost 1 billion of images from the data set. The tiniest shifts in these similarity thresholds could have excluded or included hundreds of millions of images. What the images contain plays no role at this point. So this is what curation by statistics look like. It is tiny tweaks to code, profoundly affect the content of training sets, and therefore the models that use these data sets in their computational, to develop the computational worldview. There are two important things we can learn from here. So the first one, algorithmic curation commonly depends on numeric thresholds, which are often poorly understood and are meant to be a proxy for some other concept, but are very often a very poor proxy for what they should do. So similarity threshold is a proxy for like how close a caption and an image align. For decades, data sets have been constructed using human intervention, and this generally yielded very high quality data sets, but they were too small to make today's LLMs yield any meaningful results. Lion set out to build a data set for these newer, hungrier models. They built a data set purely constructed by machine processors, running models and tweaking thresholds. Line 5B is a data set that is purely constructed by measure. But the question here, of course, is like, what is getting measured? Is it the quality of the data? Is it the capacities of CLIP? Is it the success of a model against the benchmark? Or are we measuring actually the benchmark here? And the second insight that we can gain here is that there's a circularity inherent to the authoring of AI training data sets. Because they need to be so large, their construction necessarily involves using other models, which were trained on other data sets. Consider Line 5B's similarity score, for example. It is the result of a model, CLIP, trained on a data set, which OpenAI does not disclose. And to arrive at the threshold, Lion trained another model on their own data and compared it to benchmarks, for example, ImageNet 1K. And these benchmarks are again compared to other models. And in this case, for example, ResNet 50, which set the gold standards for image data sets in 2020. We could go even further down this rabbit hole. For those models are again trained on more data sets, and those data sets are again constructed with more models. There are models on top of models, and there are data sets on top of data sets. Omissions, biases, and blind spots in these stacked up models and data sets shape all of the resulting new models and new data sets. We are creating circles of feedback here, and they keep on feeding on themselves. And it is models all the way down. So let's take a deep breath. I know this was a lot. It's very technical. It's very abstract to talk about this, and I apologize for putting this on a Saturday morning on you. But I want to point you to the 2 publications that we did. The first one is on the Knowing Machines website. It's J.R. Thorpe and I published this more in-depth investigation. It's a rather long piece. It's a lot of scrolling involved. And the other one is a publication, an investigation that we published on the Spiegel with a really beautiful URL. They really figured this out. It is behind a paywall, but if you want to have access to it, send me an email and I give you a gift link. Also, it's in German, but if you want to practice your German, it's a great way to start. But our investigations go much deeper into what I presented here and touches on other glaring problems of Line 5B, such as languages and representation. I think as artists, academics, practitioners, or journalists, dataset investigation is one of the few tools we have available to gain insight into these datasets and understand how these complex systems actually, how they are conceived. Dataset investigations not only allow us to name biases in the datasets themselves and in the models, but it also allows us to see the structural biases of the AI ecosystem itself. An ongoing problem that I see is that curation by statistics amplifies many of these structural biases. And curation by statistics is the direction the field decided to go in order to build this new generation of models. Again, it is a choice to do so. We have seen that by looking at data sets, we see the models underneath, and in turn, the data sets underneath those models. The field of AI is a pile of models and data sets, and each new layer is even less understood than the layer before. Each layer, the field takes each layer as its face value, as it is promoted. Structural problems are perpetuated. And this is why advocating for dataset transparency is so important if we want to hold AI systems ever accountable for the impact on the world. But often I hear but who cares? This stuff just works. And then I want to ask the obvious follow-up question, works for whom? Because your experience living in a data world can be very, very different than the experience that the person sitting next to you has. But now, one last thought, and to bring it back to my own experience as a journalist. So as my work, as my day job, I think it's also true for most of you actually, we curate data ourselves. A lot of our work involves actually taking data, doing something with it, and then producing data again. We often hear the moniker that the data is raw material, but I find this very, very misleading and wrong. Data is not just lying around. Data is collected, it's processed, it's transformed, and it is queried again. So data doesn't just exist, data is created. Thanks.
Well, we have questions, so is the mic?
Hi, thank you so much for your talk. Great that you were actually criticizing Clip, because in thousands of conference, people are just praising Clip and saying, "Oh, that's the tool." For example, there was a conference recently that I attended to. They were saying, yeah, that the application possibilities of Clip is fantastic, but no one actually showed any. It was like some kind of PR for people who are in data sciences. So everyone was talking about the potentials. No one was actually showing the results. And the idea that they were discussing was to apply it in recognition of visual content in libraries and archives. So yeah, but no one was actually giving any results. But what I wanted to ask you is about the role of labeling in production of these of such models, right? How would you say, because you said that it is basically curated using an AI, right? But human labeling work also plays a role there. So maybe if you can expand on that, it would be very nice. Thank you.
So human labeling actually doesn't play a role here. That's the interesting thing about this, because if you operate on this scale, there's no ability, no way that you can actually find a taxonomy and even like do the actual work. So we have ImageNet, which was like the granddaddy of image data sets. And this one has been labeled by Amazon workers, Mechanical Turks. They developed a thing where they showed one image to 5 people, and 5 people had then 5 options, and they selected it, and then 3 out of 2 won, and that was the label for this image. So this data set was very, very problematic with the labeling. Again, because they used like not a qualitative measure to label, but a quantitative measure. Line 5B and image sets like Line 5B don't rely on labeling at all anymore. They just take basically the captions of the images and then say like, well, is the caption similar to the image, and that's it basically. And that's where Clip comes in. And Clip is actually the really interesting thing here, because it is proprietary. We don't know much about it, but everyone uses it. There's a promise behind Clip, and it is like, if you talk to people in the field, everyone will say Clip was like an achievement of the AI field. The idea that you can compare 2 types of data that are different modalities with each other, that was like a novel thing, and that was like a groundbreaking thing, right? But what is happening, and this is the interesting thing, if you talk to people, it's like that they say, we all know Clip is complicated and difficult, but everyone uses it, so therefore our results become comparable to other results of people in the field. So it's not a measurement of quality. It's not about like providing good quality here, but it's only about like being able to compare yourself to like your colleague from a different university. And this is the role of Clip. Like it's actually like for the AI field, it's pretty old technology. It came out like in 2020 or something like this. But they are still using it because it's just like the way to compare your own paper to a paper that was published like a year ago.
Just about that, like how Clip was created, right? It's also a model trained on something, like then it's like a chicken, like an egg.
Yeah, it is like a loop, and they just keep on feeding itself. We heard yesterday about synthetic data, which is a very interesting topic, because there this concept of like feeding on itself becomes like very, very obvious. But we are actually already there. Like, never mind if it's like synthetic or not. But we are basically already like consuming, like for our new models, consuming the outputs of the previous models, and this is already happening for like 10 years in the field.
But we don't know how Clip was created. Right?
No.
We don't know in which data was
No.
trained.
No, we don't know the data set. We know that it's 400 million images and text pairs. That's all that we know about it. We have one paper describing Clip and the architecture, and there's the model that is available and people can apply. But the data set that is used to train Clip, it's a mystery, like every data set of OpenAI. It's like very, very
How would you approach the problem with chicken and egg situation? How would you create a data set which is accurate? Would you employ a lot of people, label it manually, or what would you do?
I would not do this at all. This is not my job, luckily. But like the thing is like the question is like, what is accurate, right? Like when is a data set accurate?
Well, we all have biases, even humans, but I think that it's better to not have a 5-question choice, but then to have a prompt right.
The thing is like I think this is a misleading question. Like on the one hand, like I think like this is a choice that the field took, right? Like they decided we want to build these models, and they decided we want to build these like data sets in order to feed these models. So I feel like it's up to them to also figure out like what the problems are, and they don't do it. But the thing is like one problem that we see with data, it's like an idea that data is just like neutral in one way, that like data by itself is a fact, right? And it's not, because like data matters very much. Like the question you put towards data with the same data will yield different results. And this is like an inherent truth of working with data, and this makes it very, very complicated. So when we ask about accuracy, then I think we also have to add to this accuracy within the context of where we want to use this data set. And as a data journalist, or like also doing human rights investigations, this was a very, very important thing to consider, that like we can only make a statement of truth, a statement of fact about the data that we're working in within the very narrow confines of the project that we're working on. Like using a different project, like it would yield totally different results.
You mentioned biases. What are some biases? Because I use AI for programming only, and I'm not familiar with some biases in the models. So can you tell the examples of that?
I mean, this is actually like a really well-researched field, and there's like a thing, a list, and I feel like these scenes that Larissa published, they contain like one episode of this scene contains actually like a list of the different types of biases that have been collected. There's selection bias, there's measurement bias, like we can categorize this, and so it matters like what data do you select, from which perspective are you coming, what is your context from which you're collecting data. So for example, like I mentioned Common Crawl, it's over 3 billion pages. But like what is really missing from the Common Crawl are Chinese pages, because the Chinese internet is a different type of internet. It's a separate internet. We're not connected to it in the same way, right? So that's, for example, like a very classical bias where you can see like, well, you have like a technical process, a crawler, that just like by itself just goes through the whole internet and tries to collect everything. But purely because of geopolitical situations, it's not able to select a big chunk of the internet and crawl that one as well. That's a form of bias. That's a structural bias that you can see in these data sets.
Where do they emerge? Like, is it, if I ask ChatGPT, for example, about some history, will it be biased in terms of that, or image generation? Or
the thing is, like, we are trying to build data sets that are representative of the world, of everything that is in the world. This is like what they're trying to achieve. Build a data set that gives a machine a complete view of the world, like things, the people, concepts, the abstractions that we work with in the world, right? And so if you don't have everything in the world that is in there, like you cannot represent the world as a whole thing. So there's an ongoing discussion about like what is actually more important in the field. Is it the model or is it the data set? So I would fall like that. I feel like the data set is actually the essential aspect about it. And if you talk to people in the field, like one attitude that they're having is like that there's a ping pong between the model and the data set. And at the moment, we're in a stage where we have very strong technology for the model, transformers, but the data sets are lacking. The data sets are like not performing well enough in order to feed these models in a satisfactory way. So maybe like one day, some scientists will figure out a way to create like really amazing data sets, and then like the model, it might be lacking. But at the moment, and this is true for a long time already, the models were always stronger than the data sets. And the data sets they're developing here, they are basically a necessity, because they figured out like we have good models and they work. We just don't have the amount of data and the data in order to make them work. Like they give us nonsense because the data is so bad. So this is like where these efforts come in, to create just like scale of data, not quality.
One question about interests. What about different entities with different interests in mind? For example, I want my model to equally represent all races, and then that model will give me an answer if I ask him to produce, I don't know, founders of USA, for example, and it will produce white people and African Americans, which is completely inaccurate. So what about specific interests shaping the quality and the output?
So maybe let's take a step back and like take like more subtle examples. So we did, Ollie and I, we did research a few years ago. We worked on a project that looked at the use of these algorithmic decision systems in local UK authorities. So communes, city, districts in the UK. And one thing is like that they were like forced to use these kind of algorithmic decision-making systems. So one reason was because of austerity measurements. The government just cut the budget, said like, we don't give you any money anymore, and use these systems because we think they're cheaper than what you are doing at the moment, right? But what happened actually is like that these people had to work with the results of these systems, and they were experts in the matter. Like it's about child benefits, it's about like unemployment benefits. Like there's a lot of like at stake here for people, for an individual person who's affected by the systems. And the experts saw that these algorithmic systems produced bad results, but they had no recourse. They had to accept the result of the machine and apply it and deploy it like this, right? So this is like one thing where I think we can show like a problem of interest. There's an interest to deploy the systems because like there's money involved. These AI systems, starting with Microsoft, Google, the investments are going into the trillions. I don't think we are aware of like the amount of money that is put into this technology. The bill is due at some point. At some point, this money has to come back. Like Satya Nadella, Sam Altman, Google, they want the money at some point. So these systems will be deployed. Doesn't matter how good they are or how bad they are. Like we will be forced to use the system just because there's so much money involved. This is an interest, for example. Yeah, I don't know. I think we can go on, but we can find a lot of examples for like interest behind the systems. And also just to add to this last thing, I think we can also reduce the interest to actually to very few companies, and these companies are all located in the same geography on top of it. Like, and even though like France at the moment is like having like a renaissance, as being like the European hub for AI or something like, it's a drop in the bucket really. Like,
Well, with that, we'd really like to thank Christo for this talk. Excellent pathway, and which is a really good connection when we tried looking into different interests. And the last question we received about this topic is to introduce our next speaker, Professor Vladan Joler, who will talk about the power, these complex relationships between technology and society. And he has received just recently an Ars Electronica award, but alongside many other awards for his other works, more known like The Anatomy of the AI and so on. And it would be a real pleasure, I think, for us to hear from him directly about his work on calculating empires. We have a parade in the city, if you didn't know what that sound was. Yes, and his wonderful ways of using cartography to talk about this complex measures. And we'll leave it to the test. To turn it on. So Vladan, really glad that you're here with us again. Thank you for being here. It's fantastic. You need, I feel, a bigger screen to show this map because
always.
In real life, this map is about 11 meters. 24. 2 times, 2 sides of 12, and we will try and explore.
Thank you, Des. And I'm really grateful to be here again. I think I was here every year, maybe 1 year.
I think you came to 2015, and almost every year, I would hope, but maybe 7 times.
Yeah.
The nicest one I think, was when during COVID, when you presented from your apartment.
Yeah, with the LP.
LP playing and the extractivism work.
And I really appreciate, because like most of the time I'm here at the Descon, I'm basically presenting things that I'm really not sure of, in the sense of like it's always like the first tests of some works. And this is, again, okay, we published this one in November, but it's still basically just in a physical form now, being exhibited in different museums, galleries, events. it's a basically large-scale installation. It have like 24 by 3 meters of really condensed visual, let's say, storytelling about history and genealogy of relation between technology and power. It is probably one of the, it's for sure one of the most difficult projects or investigations or processes that I did in my life, but for many reasons. You know, it's not just a scale; it's also a topic. It's something that probably you should not do for many reasons. One of the reasons it's like all the attempts to do history are failed to be wrong, especially because you rely on some kind of data from the past, and this data from the past is being shaped by the people from the past who were in the position to shape data from the, you know, from certain periods. So you're basically stuck into some kind of loop of power relations about like you know, who is writing a history, who have a history of who had a, you know, who had the archives in the past. So you all the time rely on something that probably it's just a reflection of power. You know? But we wanted to do something different. So we wanted to create some kind of critical reading of the history. Even we knew that it's probably not possible. You know? And I'm going to play now audio tour of this map. It is narrated by Kate Crawford that worked with me on this one. We basically, together with Christo and many other wonderful people, collaborated in this project, Knowing Machine. And this project was part of Knowing Machine, probably the weirdest part of it, like some kind of art part. But yeah, I'm really happy also to be part of the same project. So now I will try to play this audio tour. And a lot of thanks to Milutin and Oli for making this web version possible. I will explain like also like some kind of technical aspects of it maybe later. Let's try with this. Large-scale research visualization, exploring social structures evolved being to be the longer trajectory of ideas, devices, systems. The photograph represents time to the present. Across this expanse of history, the map is a part of created the condition of empire. A horizontal axis is organized into four: communication, classification, control. Within these themes are dozens of themes, from algorithm to architecture, bodies to borders. Navigation is flexible. You can read vertically to follow a single topic from 1500 to 2025, or horizontally to track different systems and events over a single time period. Alternatively, you can select a topic and the top of the screen be taken directly to that topic. If we go from left to right, the journey begins with the history of communication devices that humans have used over time. Then we turn to the interfaces needed for access, the programming languages behind them, and the communication infrastructures that support it all, from submarine telegraph cables to satellites to the electromagnetic spectrum. Then we see where the data flows from those communication systems, collected and organized by museums, film and TV archives, and AI training datasets. That data is then used to train algorithms and models
that have their own histories, which are programmed and processed by human computers and crowd workers. It is all powered by energy-intensive computational hardware that is expanding exponentially in multiple directions, from hyperscale data centers to biological computing to quantum. The themes of control and classification begin with time as a concept that orders human actions and labor, to education as another structuring process, to the ideas of emotions and intelligence and the shaping of the human body itself. We see those practices of classification and control in biometrics and medical information, through to the disciplinary systems of prisons and policing. Borders and bureaucracy trace the movements of people and information, which brings us to the heart of the map: colonialism and the paths of empires over history, with their accompanying political and economic ideologies that drive production and energy extraction. Next, we see the strata of planetary classification, from the mineral layer of the lithosphere all the way up to the astrosphere. Then we consider space in other ways, how mapping and architecture are themselves systems of control. The final sections consider the many layers of militarized power, from surveillance technologies to doctrines to centuries of military systems. Every reading is different, and you're invited to draw your own connections. Hundreds of individual drawings and texts span centuries of conflict, enclosure, and control. We suggest taking your time, a radical act in an era of speed and simplification. A close examination of these patterns over several centuries reveals the ascendance of certain ideas and technologies, the concentration of power and wealth, and the colonization of land, infrastructure, and human life worlds. In this visual history, we see how the past is contained in the present and how the future could be made otherwise.
All right. Yeah. So, okay, just to give you some kind of like insight how and how we started to do this and why and basically in the beginning it was, if you maybe saw Anatomy of an AI System, our previous collaboration. So it have this kind of backbone that starts with an object. In that time it was a Amazon Echo device, and then we deep dive through this kind of extended anatomy that goes from object into communication networks and then data centers, and then we dive into algorithms that are inside of data centers. We dive into data organization structures. We dive into labor and then into work. You know? And basically this map is the same thing. It have a same logic. So if you go from the left, it is the same. You know, this upper part is basically communication devices, and then you go into interface, then you go into communication infrastructure, data organization, algorithms, models, hardware, and so on. And then the other map, the other part of the map, is basically how those structures are basically being embedded into different kinds of control classification systems. So we have a time, education, emotions, human bodies, biometrics, medical, prison, policing, borders, bureaucracy, political systems, architecture, surveillance, military. No? So they're supposed to be one across each other, no? And to reflect each other in a way. And in the beginning, it was like, okay, it started to be fun, but when you start to deep dive into those like histories, it is really complex story. And for me, the most interesting one that I didn't basically thought so much, and it is really related to what Christo was speaking about. It is basically history of classification. So I spend a lot of time trying to understand how we classify the world from 1500s until today. Because at the end, if you dig into data sets or models that Christo was explaining, at the end there is some kind of classification matrix. You need to have some kind of classification matrix as a matrix for labeling data set or organizing data set. And then for me, this kind of like understanding the history of classification was like the most interesting part, because you start, I mean, like for example, with classification of nature, no? And you have this guy Linnaeus who classified all the plants. But then in one moment he switched, or he started to think about, okay, what about humans? If we classified all the types of animals, then we should also try to classify humans. So in one of his books, you have there are 5 different types of human beings. That's basically 5 races. But it goes parallelly for us. What was like really interesting, it is to go always parallelly with systems of power. So this is the time when you have like European colonialism expanding, and you have this parallel with that birth of scientific reasoning and scientific method. So basically you are trying in some way to use a scientific method that say, okay, let's now classify everything that we have around, but it is in the same time tool to somehow, let's say, give a justice for all of those atrocities that were happening. And you are saying, okay, we are not the same. And this is why there is 5 types of human beings, and the third and fourth and fifth are maybe not so important as the first and the second one. And this is what you always see when you start to go from there. You always see this kind of relation of systems of classification and power, you know. And also from the same stream, you have a birth of I don't know, physical anthropology that is to say, okay, now we are continuing this obsession with quantifying everything, you know. And it's the same thing with the AI now. We are quantifying human beings, we are measuring human skulls, we are measuring how tall they are, and then we are applying some kind of really fuzzy logic, saying, okay, the size of the skull means that someone is more clever or someone is. And we can also look at those kind of examples through many different fields, like classification of human beings, of like body, classification of intelligence. And then you see, for example, there is a patterns of like always you have a situations. Once you have this kind of crazy idea of classifying human beings or intelligence of human beings, usually it's first being used in prison systems, on borders, and all of those things. So, for example, the first big use of like quantifying human intelligence to IQ tests were like being used in military systems, but also on borders. So, for example, on Ellis Island, when you are immigrating in United States, you needed to fill some kind of IQ test, and if you are not on the scale, then you are being put in back. But then you understand that each of those systems of classification are coming from somebody history, someone point of view. So somehow the people from the north were getting better results than Italians, people from Balkans, and so on, so on. So you start basically critically to read these kind of systems of classification, but they go in parallel with media, no? So for me, if you scroll here on the left side of the map, and this map, it's really not for 20 minutes. That's clear, no? So it takes an hour, and this is why maybe it's radical in a sense that it takes a lot of time. It takes to dive in, it takes to take time and think about things. So then if you start, because we also did this kind of like archaeology of media, then you really see how, you know, in order to do mass biometrics of faces, you needed to have a photography. as a medium. So there are always links between the birth of medium and how this medium is being embedded in a different political context or context of control. And my love for this kind of, I remember when we were doing this early Share Labs investigations, I always wanted to have this kind of like analysis from the past. And it was always this kind of like 1850s as a some kind of like time when a lot of things are happening. So for example, if you look at this line, this is like 1850s. You have, you know, we think that we are now in some kind of like the age of magic. You know, everything is magic around AI and whatever. But if you think about like 1850s to 1900s, this is the real magic. In a sense of like, this is like really tectonic changes in a sense of like, I don't know, before phonograph, there was no voice being recorded. So we have thousands of years without recorded voice. But in the same time, look at this, phonograph, radio, telephone, telegraph, typewriter. This was like really some kind of like hardcore birth of new media, no? Not 2000s or whatever when we think about interactive media. But no. That was like 1850s, 1900s beginning when we had a situation in which you had like before that, I don't know, you needed like 2 or 3, 4 weeks for one letters to come from one continent to another. And suddenly you have a real-time communication network. So that was like really, but what is like really interesting for me in this research was like to try to understand how for each of those media, basically how the power it's embedded in. And so for example, if you think about like the time before voice was like recorded, it was completely different feeling. You know, you have a band, you go around and the voice goes with your body, you know? And then suddenly the voice is embedded into some kind of plastic, you know? And start to travel without you. And then around that media, you have a lot of parasites like managers, publishing houses, building their own industry, and artists is like being left there. But okay, as artists feel, okay, when I go to the next city, they know me. And this is typical, the same thing what we have now with the internet and reputation economy and AI and everything. They say, okay, you know, maybe I'm not getting anything of it, but how many likes I have, you know, like so many people are listening to my music. They say, oh, good you. But there is a basically ecosystem around it. So in a way, we can somehow, if we start to critically analyze all of those media, we can find like so many different stories that are basically absolutely the same system that we have today. And then, for example, for me, it was like some parts were like more interesting than others. I was thinking, okay, history of the infrastructure, because now it's clear, okay, you have a networks, you have a, you know, these towers of like mobile systems, but then how those infrastructures were in the past. And we did a lot of like thinking about, I don't know, postal systems as a networks, you know, like as a some kind of predecessors of like the infrastructure that we have now. And then again, you have a same story. This is this story about the stamp. How basically in UK back then you had, I don't know, many different small this kind of like courier systems, independent of the state, going around selling, bringing letters, and you were able to exchange like 4 different mails in one day. So it's some kind of birth of social media back then. But then again there was some kind of like terrorist, whatever, attack secret services, and they said like, okay, we need to conquer this space. And what they did, they invented the post stamp. They lowered the price from, I don't know, 10 cents or whatever to 1 penny. You know? So this is why it's called like penny black. And by doing that, they centralized all the communication. And in the same moment, you have a birth of some structure. It's called the black room, in which basically all of the letters are coming through one same room. And what they do metadata collection. So it's a birth of metadata collection, because what is on the stamp, what is on the letter is basically metadata. From who, date, whatever, the same metadata that we have in emails today. So if you go back in the past, you will see the same things, the birth of same things and same kind of power relations that always goes. I remember when we were like doing this investigation of like, I don't know, Serbian internet service providers. And then you have this relation between government and internet service provider. This is the same thing, same relations that existed in 1700s and 1600s between the state and the infrastructures. You know? So it's for me, it was like super interesting to deep dive into it. And then this part, it's about like history of basically data collection and data organization. So what it even means. And then you see again the same power structures. You see which countries were brought the concept of museum, brought the concept of archiving. So again, it's a UK, the same, you know, like power structures that exist today. But this concept of archiving is also really related with the colonial explorations, okay, the however they call that, going around and numbering everything, collecting everything, and bringing everything to British Museum. No? So it is basically the same way as today, it is a theft of cultural history. So what ChatGPT or OpenAI are doing, it's a theft of cultural history. They took all the books that exist in the same way that British did in many hundred years ago. And then it's a super interesting story how data is being like organized. So for example, before, again, combination of one medium, for example, printing press, before printing press, you didn't have like numeration of the pages. You didn't have a content page at all because you didn't need it. You didn't have the scale of books. You didn't, and each of book was like handwritten. So you don't have this system of organizing knowledge. And then once you have a printing press, then you need, you know, numeration of pages, content pages, and all of those as a technologies of knowledge organization, page layout, pagination, everything. No? So it's really interesting to think how in history we were like organizing data and how basically for me, like, you know, they completely, is history of librarianism, it's completely forgotten now in a sense, but is a core history of computer science. Computer science doesn't come from computers, it comes from libraries, organization of knowledge and systematization of knowledge and stuff like this. Another completely crazy one, but I will not go into it, is a history of statistics and history of basically algorithms. I had a lot of fun with this. It was hard, but but it is, and it is also like really interesting to think about again these kind of parallels, like when you have a birth of statistics and a birth of probability, you have in relation again with the colonial expansion, because the idea and again with the systems as an insurance. You know, probability is about insurance. You know, so you are sending 5 ships, 3 of them are coming back, but what is the frequency of these, so that you need to calculate the cost of ships that are not going to come back into your business. And then you have basically a birth of statistical thinking and statistical reasoning, because it was needed for a capitalism to expand. So basically, so you have like really crazy stories about like, for example, regression as a statistical system of it is like, for example, first visualized by Galton. Galton also is a really infamous guy that is kind of in the root of eugenics. So this kind of regression was like related into like counting human beings and how they will reproduce and who we need to you know, like put away and so it's like super interesting to read those kind of parallel stories that are most of the time hidden from us. And then basically this second map, it's really hardcore. It is about like how we classify bodies, how we are classifying race as a taxonomic concept, different, you know, gender related things, eugenics. You see the history basically of not misunderstanding. You see that the classification systems are constantly changing. So the classification system that we have in this moment are basically constantly changing, and we are constantly being wrong. You know, we in like, I don't know, 50 or 100 years ago, we were thinking the gender, it's like just like two options, and it's not an option, it's a line. Basically, it's a spectrum. Now it's even not a spectrum. Now it's like some space that you can jump around. Now it's a dynamic thing, you know. But all of those are basically classification systems. No? And yeah, that are basically being embedded into different kinds of, so we have like history of prisons, laboratories, prisons as a concept, panopticon, everything. Yeah, I'm inviting you to browse this. It is really maybe weird experience because it's not even organized as a database. Because like you have, for example, in some moments here in the map, you have like moments of like really precise data, like date, time, but then in combination with some kind of abstractions and visual representation, combination of like some kind of philosophical comments together with factual data. So it is really some kind of like a huge, huge, huge non-linear, multi-dimensional storytelling device about critical history of relation between technology and power. And we can criticize why, again, this is completely not possible and nobody should do it. Because again, on top of all of those problems that I said about like how we read history and how we are not able to access information and how everything is biased. Anyway, this map, again, it's a new classification system, you know, so it's a classification system within the classification system within the classification system. But when I'm approaching these kind of things, and I had a similar problem in the past, I am aware of that in a way. So I'm basically some kind of using in a way of like appropriating some technology, because the maps are basically military technology. So I'm appropriating military technology with the idea that I know how powerful and how bad they are in a way to tell a different story. But it is some kind of absurd space that it's kind of like a map that is criticizing classification system by itself. It's a classification system. Yeah. Okay, questions?
So I'm Alex from Germany. Thank you very much. Extremely impressive. I just wanted to suggest the idea that this is like static from the view from today. But it would be very interesting to add another idea. Let's say, how did people in the past project future inventions and future dystopian ideas about control? And then you could use that as a projection to the future. What future ideas today could be about future technology and future control.
Okay, so thank you really once more for this nice presentation. I've seen a few others of yours and they're always make you think, so this one especially. And I would just like to ask you about that part that you mentioned, the relation between information and control, maybe in that part of this whole thing. So did you maybe notice a trend or a pattern through time? How did that happen? Like you mentioned, there was like books, people writing books, then there were libraries, then there were archives, and I guess then came some censorship or something like that. So is it that way with which steps are like following which? So what does happen first? Do people create data? Does data then get, I don't know, encoded, like stored? And maybe somebody then comes with an idea to control it, or to like either for profit or to keep the power or create the power from that. So is that, or, and especially, is that a one-way street, or is it also a way for people to like keep what they actually created for themselves and use that power for themselves in a way?
So the pattern that is kind of repeating, seeing like once you have a new media, like I don't know, phonograph, telephone, whatever, it creates a new territory. And for capitalism, it is really capitalism. It's into expanding into different territories. So once you conquer all the land, and so the first was like going around and capturing flag and putting flag into different resources like minerals, mines, whatever, no? Doing extraction. But the media, creation of media or technology is creating a new territories as well. So you create a new territory of voice being embedded into something. So and then what is going, so first it's a conquer technology, then it's a basically enclosure. And this is what they're doing now with AI. They're going to enclose the territory of AI, like several of them who is able to play this thing. But it's the same thing as a birth of American bourgeoisie, Rockefellers and others that were like basically building their power on either resources, like gold mines or whatever, either infrastructure. So it's the same. So, but after some period, they're going to enclose this and going to commodify. Commodification doesn't need to go in the same moment in the beginning. So for example, with OpenAI and whatever, we don't have a moment of commodification. Now it's a moment of enclosure. Now it's a moment of glory and of growth and to conquer the territory. But once the territory is being conquered, it's going to transfer into commodification. And then it's going to end up in the shit. Then we are going to end up again in a monopolies and things like this. So you can also always go. This is like my favorite part of the map. I mean, is this, I don't know, this is absolutely the same thing as today, no? New imperialism, basically you have a new forms of technological imperialism, technological colonialism. You have a monopoly capitalism of few different companies. You have new form of industrialization, basically new form of automation that is coming with this. So it's coming absolutely the same. And then, you know, like collapses of this economic laissez-faire economic system. You have financiers, you have banking systems, equity markets, stocks. But this is not 2025, no? This is like 1800 something. Industrialization. But what we miss in this moment is this. For labor right concepts. We don't understand new labor relation between us and those systems. But what is our labor relation towards like AI system? You know, like there is story we are going to lose job, but in a way there is some kind of labor. What is our labor relation towards YouTube? You know, some people are being paid for being popular. I don't know. Like it is, we still are not able to define this. And from this, it will probably come this labor wars, riot, maybe this, maybe not. This is like core of everything. Taylorism. Once you are able to, you find like, you know, someone making a shoes, then you cut this into 7 different, you know, steps or 100 different steps. Once you are isolated this into steps, you're basically creating an algorithm. Then you don't need any more a worker because you don't need the skilled worker because each of the workers will just do this, and then you have a birth of manager as a job, because before this you didn't have a manager as a job. No? So we are kind of all the time there. It's not a loop. It's maybe different, but in a way it is really interesting to learn, to understand that it's that this process of enclosure, capture, and everything, it's not new. It was like, you know, all the time there. It's all about, again, if you think about AI systems today, it is about resources. So it is combination of some kind of traditional colonialism, like resources extracting from Congo, from lithium in Serbia, but it is also a new forms of extraction of knowledge extraction, you know, all the books. But it is interesting to think about it in and then, for example, again, to come back to this Taylorism, you know, for example, I was like completely enjoyed in the situation in which I realized that the Gantt chart is basically born in the same time when the Taylorism is born, because they needed a visual representation that can serve managers to control workers. So all this kind of visual history of visual representation, it's also political history, you know, like and so on, so on. So many different dimensions, so many different stories to tell. Sorry.
Thanks, Adam. Very incredible project. I kept thinking about Abby Warburg's Builder Atlas, the Memoscene Atlas, in looking at it on several levels. Obviously, the visual aesthetic is, and also thinking back to what we were talking about yesterday about darkness. I wondered if you could say a little bit about the design aesthetic, and also Warburg's idea of the Nachleben, that, you know, you can link things in the past through to now, and things get carried forward back to Nietzsche, eternal return, etc. I'm struggling, and I wanted to just maybe say a bit more about the pathways, because they seem to me you're saying what Warburg was saying is that things do recur. At the same time, you're saying they don't recur as a loop. They're like also a shift. So maybe just say a bit more about that.
We wanted in. I mean, we didn't know that it will go so far. The problem was like. I was expecting from Kate Crawford to be one to say this is too much, but basically both of us are really obsessive in different ways. So there was no one to stop this growing, except we had like some kind of like after 4 years, it took us 4 years. So after 4 years, we had some kind of like invitation for some exhibition in Milano, and like, okay, let's do it. But we, in one moment of because we spent like literally 2, 3, almost 4 years living inside of the map, you know? And this is done in Miro. This kind of really, it's not made for this. And the best, basically, it's still space where you can go, and like we lived there, and there was like a lot of different iteration of it. One moment we realized, okay, if we start to connect things between each other, it's going to be connected everything with everything. And once it's grown on the size of 20 meters, you will have just like a lot of horizontal, vertical, diagonal line. Even this is too much to process. So we said, okay, no links, because that's like a rabbit hole of like everything is connected with everything. So we are just going to provide nodes, and somehow we hope that somebody, some imaginary viewer, is going to have fun by connecting nodes but itself. I know it's not possible probably, because like behind many dots here are like stories and it is some kind of invitation basically to explore different nodes, and maybe to create your own narrative out of it. So I'm completely aware of how. But it is interesting, like I'm encouraging people. I don't know when we are going to do exhibition in Serbia, probably not soon, but it is interesting. it is interesting experience to see this map in the space, because then you move around. It is different form of, because like we are all so tired of screens, no? We are tired of screens. It is zooming in, zooming out. It's a different form. Once you have like a body relation with that size of like really condensed thing, it's a different, and people do react like really nice in a sense. Like I was thinking that before we printed first time, I was thinking like people are going to throw up, and it's not going to be a pleasant environment. But in a way, it's not so bad. It's like okay. Sure. But yeah, yes and yes, yes. It can be whatever. It can be a lot of things. It can be a VR experience. It can be it can be database. Maybe the best way to do it is via database. But the thing is like it's a long story of for me. Maybe this one really went crazy, you know. But the thing is like you can have those like maps. Two-dimensional maps are n-dimensional spaces, because you can embed it is similar with the data sets. Like for example, once you stop to think about the 3 dimension of space and 1 dimension of time in that way that we think about, if you think about in the sense of data, each column of one Excel sheet, it's another dimension, no? It's another dimension. So this one is like location, this. So you understand that there is like a possibility to have like 10 different dimensions. Then you say space, third dimension, it's maybe not important. But but when you are doing cartography, when you are doing mapping, you can embed 5 different dimensions in 2 dots and 1 line. The dot can have a size, it can have a shape, it can have a color, it can have, I don't know what, the line between them, it can have like a relation of, you know, directionality, it can have a tag, you know, so even in 2 dots and 1 line, you can embed 10 different dimensions. And in that sense, in two-dimensional paper, you can have 25 different dimensions if we want to play with that. And then the real third dimension, it doesn't make sense. So for example, I don't use color because aesthetically I don't use it, but in a way, color can be another dimension. But I don't use it because I think I don't need it. And also I'm afraid of print because it will always go wrong. Color.
Just a short suggestion. You don't need to print it out. I thought about doing a projection. I think it would be very good, very well suited to a big dome or spherical structure. Yeah. I'm thinking about a special structure in Germany where the dimensions would be good and which is very well suited for video projections at a spiral staircase. You could look at it, maybe it's something like that. That's a surrounding.
Yeah,
you could have it 360 degrees.
It is still like we are doing print, and print it's so almost at the edge of possibility. You know, human scale. Human scale, it is important. So it's 3 meters, because if you make something bigger than 3 meters, people will not be able to read what is on the top. No? In any format it will be a lot of things. You know, a lot of projectors, because none of the projectors can have this resolution of being. Yeah, some of them, yeah, big ones.
It's more
like kind of
I do, but still I'm traditional.
visualize.
I'm traditional new media artist. I do paper. But someone told me on Ars Electronica how this should be because like they saw people. So when it's printed, they saw it printed, and then when you step out and see people how they are like going in, out, and around from map, and how people interact in physical space, someone told it should be in the interactive art because like people are moving, interacting with even if it's a piece of paper.
So we have one question online. Sorry, before you go. Yes, it's again from Monica Ahmed, journalist. She's asking, has the map reserved some space for putting sand in the gears against the system evolving?
In the gears, what it means?
Sand in the gears. That means like something to block. I think
okay,
there's a
okay.
German expression, stones in the gearbox.
Okay, so yes and no, in a sense of like we didn't. This map, it's not map of solutions. So it's just like map of digging the problems with the idea that people, by like understanding the problems, will be able to create solutions. But there is so much uncertainty in this, and I think if something is sand here, it's basically this kind of fields of uncertainty that exist between events. And this, I found, for example, drawing to be this kind of field of uncertainty because, like, okay, when you add some node that have a time, name, and whatever, it's kind of fixed. But you have when you have a drawing of some kind of abstract relation, then it's kind of every interpretation will be different. So in a sense, this kind of fuzziness is a way to provide some space for thinking, rethinking, or whatever.
With that, we'd really like to give Vladan a big thank and huge round of applause for all the sweat in working on this. So we have been running a tiny bit late, so our next speaker has been lined up and online ready to join us. And I'll just briefly say, introduce him as an old friend and a colleague, but also it's Jari Arkko, joining us from Finland today. He wanted to be here in person. He's a senior expert researcher in Ericsson, but he's also an internet geek, and you can read his bio online. He was an IETF area director, Internet Engineering Task Force area director for many years. Can you hear us, Jari? Are you on?
Yes, I can hear you. Can you hear and see me?
Yes, we can see you and hear you. Thank you so much.
Yeah, and
you have
see
about.
my slides as well.
We see your slides as well, so it's all working well. And you have about, I think, 20 minutes or yes. So please go ahead. Thank you.
Yeah, thank you. And hello, Descon. Glad to be with you, even though it's remote this time. And I'm going to talk about networking and the environment. And I know that's a dear and long-term topic for, I guess, maybe all of us even, but certainly most of us. So in some sense, that's not a new topic, but I wanted to highlight some of my own views on this topic, both on the angle of diversity, how diverse the topic actually is, how many different aspects it has, and also some recent technology work and how that might impact things. Also, I'll be talking a little bit about data collection and sleeping. I don't know how people slept last night. I slept not so great, kept waking up and doing some micro sleep, and that's not great. But for computers and networking gear, that might actually be great. So we'll get to that in a second. anyway, so just starting from the high level view, how does networking impact the environment? And of course, it can be an enabler for good, for the rest of the society to be more efficient. Again, I'm sorry I'm not there, but on the other hand, I'll be burning a lot less fuel doing this talk this way than by traveling with airplanes and such. There was a 2014 study that looked at video conferencing compared to in-person conferencing and found that at most 7%. And I think that's, well, it's a 10-year-old number, probably, it's much smaller percentage that we burn on video conferencing, given that it's quite commonplace technology these days. But anyway, so this is just one example of the kinds of things that networking enables us to do. And that's great. And there's other examples. Climerco is one thing that people have done. You can measure the environment, be more aware of what's going on in the environment in terms of air quality or many other aspects. And so ton of things that the network can do for us. So that's one aspect. But of course, as you know, the internet or the networking can bring some worse aspects as well, from, I don't know, spreading misinformation to all kinds of other things. And one thing that I want to highlight here is its ability to sort of speed up or enable massive amounts of consumerism or perhaps unnecessary consumerism. And maybe I'm just picking it up on one easy target here, but I looked up the production rates for clothing, and the number of clothing items has risen twofold in between 2000 and 2015 for this research that I'm showing here. And even though the number of people is, more or less, I mean, it grew a little bit, but not this much. And then the average number of times we wear an item is going down. So that sort of shows that we're consuming more and not necessarily benefiting so much from that. So we do need to remember these bad things as well. And of course, the networking can consume a lot of resources by itself. And this starts with the raw materials that need for various kinds of equipment, be it rare earth metals or other kinds of raw materials, water and so on. It takes a lot of labor to build stuff. So there's a lot of embedded carbon also inside, let's say, a phone that you buy, or computer that you buy. Of course, you also burn energy when you're using the equipment, your phone or a router, or you use your ISP networks for something. And there's been a lot of studies on this and a lot of different numbers. I just wanted to highlight one particular number that we looked at when I was in the Internet Architecture Board, and we held 2 years ago a workshop on the environmental impacts, and sort of tried to summarize a little bit these numbers. Michael Welzel summarized that nicely, I thought. He came up with the range that the networking aspects or the internet aspects are somewhere between 0.5% to 1 plus something percent of all of the world's energy consumption. That may sound like a small fraction, but of course that's like massive numbers. And with many of the other aspects of world's energy consumption being looked at very hard, and people actually try to make significant improvements there, then there's a potential for the ICT aspects of energy consumption to rise in proportion. And of course, this depends a little bit on how you define the networking or the internet, if you include data centers, for instance, or not. Anyway, on the right, you see a little bit of Michael's rationale, how he came to a particular calculation. So ICT is maybe 3%, and networking part of that is maybe 1%-ish. But a worry, nevertheless. Some of the growth numbers, there's also a lot of variation in this, in particular of the predictions. One issue with the predictions is that you often, I think, mistakenly take the predictions based on like, this is how much energy we use now, and this is how many bits we transport this year. And next year we're going to transport, I don't know, 20% more bits, and therefore that equals 20% more energy. And that doesn't necessarily work that way, but it's nevertheless the entire ICT energy budget is growing, and that's not great. One sort of important aspect, I will return to this a bit later, is I think this is from David Sheehan's paper from 2 years ago, where he discussed the nature of where the energy consumption and power consumption comes from, and it seems to come in his research largely based on upgrades that you sort of dimension things for the worst case of the peak demand, and then as the demand does grow, then eventually you feel like we need to upgrade now to get the bigger router or whatever, and if the router isn't working optimally, like can't scale its energy consumption to the actual demand of this particular time, then we're kind of wasting energy just because of these upgrades. I do want to make the point that we can actually make ICT technology much more efficient, and then there's some good proof points. Of course, various specific pieces of equipment and specific technologies are, could name many examples, but one interesting angle is that in Jens Malmarin's research from 2022, they looked at different operators in Europe. I think this was maybe just the mobile operators. I'm not quite sure. I can't remember. And during they looked at this for a long period of time between 2010 and 2020, 10 years. And during that time, the data amount actually rose 20-fold, but the electricity consumption was quite stable. And so one of their conclusions is that the electricity consumption is maybe more related to the number of subscribers than number of bits. But nevertheless, it's not going down either, so that's not great. Also, when we talk about the side effects of networking, we should also remember that it can be it is a basic human need, or at least is, in my opinion, a lot of other people's opinion, that you do need to communicate. You need to have an ability to talk to your friends and family. You need to get information. You need to be able to work from where you are, and so on. So it is very much needed. So the question is, what can we actually do? Can we improve things? And that's of course should be high up on our agendas. And again, I want to try and convey the message that there's actually multiple things, that sometimes people are too focused on, like, let's do one thing, that there's one answer. We need to stop watching cat videos, or we should watch them at 240p, or turn off our phones during the night. Kind of like simple solutions, but it's not a simple problem. It's complicated. And just to highlight this is from our IAB work on this topic, and just looking at like what different contributors have looked at, and the map of those topics is quite diverse. So you have anything from societal issues and benefiting these other fields, like enabling the video conference instead of flying. But then you also have a lot of like understanding and measurements that we need to understand what's going on. That's like step one for any improvements, obviously. And then when it comes to improvements, there's again like plethora of different things. Depending on who you are, you will naturally gravitate towards a particular angle in these improvements. If you're a programmer, then your angle is maybe, how can I improve my algorithm? How can I improve my software, the implementation aspects? Or if you're a chip vendor, then, we'll, migrate to a newer technology in the chip design, and then, we can cut down the energy consumption by half or whatever. But it's also lots of other things, avoidance of some things, even like, some of the proof of work crypto mechanisms are not really beneficial from an environmental point of view. So if we really don't need them, then we perhaps should avoid them. And then there's lots of like what I should call like technology aspects. And of course, if I work on routing protocols or whatever little piece of technology, then I'm going to think that I can tweak these technical solutions slightly in order to make improvements. And the sort of the message here is that it's not one thing that we need to do, but it's multiple things. And all of us actually have to, like, whatever our field is, then please focus on your field and try to improve what you're working on. It's not going to alone save the entire world, but if you take all of these activities together, then that's going to be helpful. So summarizing, the improvements come in many different forms. Maybe the number one is the second order impacts, enabling the rest of the society act in new ways, that we do the video conference or whatever other thing that's better, or get more information about the quality of the environment today, like with the air quality measurements. Of course, energy sources is also, it's like basic simple choice, like are you using green energy or something else for running your network, for instance, but that's a fairly important factor. And a good chunk of the ICT industry actually is pretty keen on these greener energy sources. I don't have an exact number for that, but some well-known brand names do quite a lot of this. But of course, that alone isn't enough, because there's only limited amount of that available, at least for now. And so if you happen to buy that, then somebody else can't have it, and so on. So we do need to actually look at the energy consumption and not just switch to greener source. And then implementation work, that's hugely important. I think people, like I've spent a lot of my career working on standards and sort of basic technologies, and our instinct is always like we'll change the standard to do something, but the implementation guys' efforts is hugely important. Then we have the technology aspects, protocols and chips and all of that. And then we talked about the measurements and awareness, transparency of what's actually happening in your network and my network and so on. That's important. And then avoiding the obviously bad stuff like some of the crypto solutions. I see some messages on the screen. Should I do something about it? Okay. Yeah, wrapping up. So a couple of things that we can do actually. One is importance of making sure that our equipment is actually running in power proportional mode, so that we don't waste energy when we're actually not using. And here, research basically indicates that our networks are typically like very, very underused. Here's an example of a Swiss operator running 2% of the network is actually being used or utilized, which is very low, of course. And that's very typical actually in many networks for various reasons. Business centers don't have a lot of users in the night, and suburbs don't have many users during the day, and so on. And we can do a lot of things for this. Actually, we can do load shifting, that we try to actually leverage the times when for some, like when there's low demand for something else. We can have better implementations. We can turn off components. This has been like a really big thing in the last couple of years, and there's even more work now. Recently, ITF is establishing a working group called GREEN for enabling better measurements from network devices, and also the ability to turn off individual devices and their components from a management angle or management stations. And also in mobile networks, you have a lot of interesting designs. You have this ability to turn off not the whole entire system, but like the tiny components that drive the transmitters. This power amplifier that consumes like almost 90% of all the energy in the network. But if you can shut those down more often, that's good. I'll just show one example of that. So this is like a technology improvement. In 4G, you had a mandate that you have to be able to transmit certain synchronization signals quite often. I think it was like every 0.2 milliseconds. And then you see like the graph of energy consumption looks like this on the upper screen. And then on the lower screen, you have the 5G version where the times were increased significantly up to like 800 times in some cases. And this means that equipment only needs to wake up now and like far less frequently, up to 800 times less frequently. And then you can burn the energy only during the time that it needs to wake up. So this most energy consuming component, the power amplifier, only needs to be on a fraction of the time. And this has had a huge impact, I think. We're, at least from a technical perspective, it's not necessarily realized in products, but from a technology perspective, you could get easily 10x improvement in number of bits per unit of energy that you can send. That's great, of course, and we actually expect that to, like, the future generations like 6G will have a similar improvement, because there's some runway left in these mechanisms that I'm showing here. Wanted to briefly mention minimal data sets as well. So the amount of data that you send is of course hugely important, and that could be multiple different things. And the large data size does have many negative consequences, from energy consumption to latency to privacy misuse of data. That if you send some information to a service, then they might misuse it, or it might leak, could be attack target, and so on. And there are multiple techniques that can help here. There's some privacy techniques. I won't go into details of this. There's better compression techniques. Recently, we've migrated more towards this binary type of designs, like HTTP2 has a better compression of headers than previous versions of HTTP had. And many other protocols still need similar improvements, but we can make improvements here. There's also possibility of using this AI-based compression mechanisms called semantic communication. Actually, that's a typo. It should be semantic communication. That could improve things, but the bottom line is that we should actually design systems and protocols with the data that we absolutely need, not to collect everything just in case, and in case we can sell it to somebody as data about consumers. So that is the starting point, actually. But I'll stop here, and yeah, thank you. And if there's any questions, I'll be happy to take them.
Thank you so much, Jari, for all that information you have shared, how to look differently on how the networking impacts the environment and all the ideas. And to say that on our live stream, we suddenly had a jump to over 200 viewers once you showed up. I don't know if it's anything to do with you, but I don't see any questions. Yes, there's one question, and we have a hard stop for the next speaker as well. So we only afford one question, and apologies about that.
Shoot.
Hi, Jari. Thank you very much for your talk. It was very illuminating for us who are not so in the technical world. I have a short question to your presentation. When you were talking about these technologies that enable micro sleep of the machine, right? But is it something that is implementable to all technology, or is it something that that has to be reinvented for every piece of technology that is used in this complicated system that you were?
It's a very, very good question. In general, the sort of the implementation related aspects are quite application specific or equipment specific. So you may have to do things again for different things, and certainly like the examples about standards for wireless like 5G and 4G, they are very specific to the radio design of those systems. So on a Wi-Fi network, there's other mechanisms, and like, of course, similarly, you want to increase sleep, but but their design is slightly different. How you schedule transmissions, so you have to do a slightly different design there. But there are some things that are general. So processors and other chips today are increasingly capable of doing these microsleep mechanisms. I didn't have time to talk about that, but like we built routers that use CPUs for some processing tasks, where we can put this CPU into a sleep mode and like significantly reduce the CPU power consumption when there's no work. Whereas previously you could only do that like for relatively long time periods, and it's kind of cumbersome to bring it up. Now CPU manufacturers have implemented features where you can do that much more rapidly, so we can get the real microsleep and not the, I don't know, mega sleep.
And one more little clarification for us to understand better. When you add up all those places where you spare energy, is the difference at the end significant from one generation to the next?
Oh yeah, if you remember the one chart where I showed that the amount of data traffic went up 20-fold and energy consumption stayed more or less the same, that would not be possible without continuous stream of these kinds of improvements. So there's a lot of hard work by various engineers in the industry to make this kind of stuff happen.
Thank you so much.
Well, Jari, thank you again for being in Descon virtually this time. We really appreciate your time and talking to us today. And we hope to see you again at Descon in person next time. So really a big applause. We have 2 screens. 2 floors with different screens, so people are all over the venue looking. If you see our small venue here, there are other people downstairs as well. See you online. And with our next speaker, I'd like to also introduce, and he's also a great friend, and we had a project that he'll talk about. He's the CEO of .asia, domain name registry based out of Hong Kong, Edmon Chung. But the research that his NGO has done is quite relevant and follows up of what Jari talked, the impact of networking on the environment. And they've created the Eco-Internet Index called the EII. It's a composite indicator to measure and compare the eco-friendliness of internet infrastructures across jurisdictions. So they started with Asia, and we have plans to do it in Southeast Europe as well. Welcome, Edmon. It's really great to see you. We know you have a lot of hard stops, so really thank you for being with us, and the floor is yours. Welcome.
Thank you, and thank you for having me, actually. Apologies for not being physically there, but hopefully next year. So as Desiree was saying, in fact, actually, many of the things that Jari has mentioned actually, I will be repeating a little bit, in a sense that the Eco-Internet Index project that we work on actually tries to model that some of those concepts into a kind of measures. But before that, just quickly, I'm coming from .asia, and what .asia does, of course, is we operate a top-level domain. So instead of some domain.com, it's domain.asia, and that's where our income comes in. But .asia operates as a not-for-profit organization, and that's why we're engaged in some of these types of projects. Of course, basically all the income that comes into .asia for domain registrations go back into supporting internet development and adoption around Asia Pacific. One of the projects that we're very excited to work on is the Net Mission project, which is the world's first youth engagement program on internet governance. In fact, we started in 2009, and it's still running, and that's one of the things. But back to today's topic, actually in 2016, when the Sustainable Development Goals were put into action by the United Nations, Asia worked on a project which we call the Agitora project. We picked the little tiger and looked at the Sustainable Development Goals, and we produced a project that talked about how the internet impacts the sustainable development and also the environment. And this is part of the program since 2016. In 2020, something, I guess, when the pandemic hit, one of the things that really became kind of came onto the headline news is how the internet is the carbon footprint of the internet is growing rapidly, especially with video and video conferencing. There is a narrative that talks about how many trees you kill by watching Netflix and so on. So actually Asia and APNIC at that time started working together to look at what the overall narrative should be, because obviously the internet, we don't think that the growth of the internet should be curtailed just because of some of the energy impact. But of course, as Jari mentioned, there is the good and the bad. We cannot lose sight of the bad either. But what is that balance, and what is the narrative that we should look at? So between 2021 and 2022, we worked with a group of advisors to look into the particular problem, to look at how do we model a kind of measure that is, again, it is not exactly calculating what the carbon footprint of the internet is, although that is one component. But also, what it replaces. So basically, we're looking at a narrative whereby, of course, we know as the internet grows, it consumes more energy. Of course, better technology that could be adjusted, but there is no hiding away that the internet, the infrastructure requires energy to support it. But what is it replacing, right? I mean, the physical footprint, the thing that the internet networking is replacing might actually be more carbon heavy, approach to life. So how should we think about it? And especially, what the internet advantage is, and how do we weigh between the two? And that's really what ultimately we came to a multi-factor composite indicator based on 3 axes: economy axis, energy axis, and efficiency axes. And actually, Jari mentioned a lot about the importance of the energy that powers the internet. That is probably the most important thing. And the other thing is about the capacity, because as Jari's graph showed earlier, it goes up in a discrete manner, right? When you add capacity to it, it doesn't, the energy requirement doesn't go linear. It actually jumps every time you add capacity to it. So that's part of considering the efficiency. I'm not going to go into the details of the actual model and formula, but instead I will let a little video explain to you a little how the composite indicator works.
Global carbon emissions bounced back after the pandemic to the highest level ever recorded. And the internet's carbon footprint is part of that growth. How should we think about the eco-friendliness of the network? The Eco-Internet Index looks at 3 dimensions: economy, energy, and efficiency, linking and balancing between the positive aspects of digital transformation along with the negative draw on power consumption. The economy axis looks into the internet's relative carbon footprint against the displacement of old economy trade by the digital economy. The energy axis zooms in on the carbon emission factor and renewable energy sources that power the internet. Finally, The efficiency axis considers connectivity speed against the excess capacity that is supporting the network. Of the 14 Asia-Pacific jurisdictions studied this year, New Zealand and Japan came out on top. New Zealand had an early start, having built the first hydroelectric power plant in the southern hemisphere, dating way back to 1885. Japan was one of the largest oil and coal consumers in the world as recently as 2019, but is now Asia's third largest producer of renewable energy. Both countries rely on sound policy intervention. New Zealand had a head start, and Japan turned things around with impressive digital transformation. Together, we must work in a multi-stakeholder way with our industry and governments to make the internet more eco-friendly. To learn more, go to ecointernet.asia. Do more, waste less. Global?
Yeah, so that's the thing, and actually a lot of it is around the SDGs as well. It touches on various different things, as mentioned, from the economy side and different sides. I don't know why the video, the background music is not coming out. It's a little bit weird. That's a weird bug that I'm not sure why, but sorry about that. So overall, what we did was look at the different axes and the calculations. So the first rankings that came out for the Asia Pacific region, we launched it at the Kyoto IGF last year, and we're looking to continue to update it. But one of the things that is important is also what the narrative is. As Jari also mentioned, the awareness is important. So raising awareness is one thing. The other one important thing about the index again is that of course the ranking is fun to look at and so on, but it's more about a narrative to talk to people and talk to governments and policymakers to look into the issue. And one of the interesting areas is what kind of policies, how can we respond? Jari again mentioned a little bit. Now I'm going to show a couple of narrative discussion, points that based on the research and based on some of the numbers we're looking at, we're looking to talk a bit more.
Data traffic on the internet, like the subway.
I don't know where.
Of data traffic on the internet, like the subway train system. Each byte of data, like a passenger, and the internet bandwidth, like the size of the train. If everyone takes the subway at the same time, we'll need bigger trains and increase the total number of trains that can be on the tracks at the same time. That is called the peak hour or peak usage. But if the same number of people travel at different times throughout the day, we only need smaller trains and also less number of trains at the same time and still get everyone to their destination. That way, we have a more efficient system which saves energy. Same for the internet. If we better utilize the capacity of the network by moving it or splitting activities across non-peak hours of internet traffic, for example, data backup, video downloads, mass emailing, etc. You may think that changing only your internet may not have a big impact. Imagine if all the internet companies and your favorite apps and games become more carbon conscious. Together we can make a big difference. Internet has a carbon footprint too. Together we can do more with the internet and waste less by promoting more efficient use of network infrastructure.
Edmon, we're getting some scrambled noise.
More renewable energy resources too. To learn more, go to ecointernet.asia.
So that's one part of it, and I'm gonna show one more video. I don't know why the video is coming across a little bit strange, but hopefully you can get the gist of it. But another thing that we realize is that part of the policy narrative needs to also think about when we talk about expanding the network, extending to especially rural areas, sustainability actually can come hand in hand. And that's one of the things that we're looking at.
Japan is number 2 on the Eco-Internet Index 2023. Not only did Japan turn around its reliance on fossil fuels, it is tackling climate poverty at the same time. And partnering with nations around Asia to decarbonize with clean and reliable energy, which helps eradicate poverty and drive economic growth. Experts recognize that improving access to clean energy reduces poverty by increasing education and improving public health. World Bank says that solar-powered off-grid solutions are crucial to connecting the poorest and hardest to reach. That means digital inclusion, which brings the education and economic benefits of the internet to even the remotest parts of the world, must be powered by clean energy. Our friends at .uz are doing exactly that with the IT Village project. Instead of having mountain kids travel to the city, the IT Village brings the internet to the mountains in the Samarkand region of Uzbekistan, teaching school children media literacy and coding, providing youth essential skills to thrive in cyberspace. What is more exciting is that the IT Village is powered by solar energy. Digital transformation and sustainable energy comes hand in hand. Perhaps that is why Japan is #1 in digital economy, according to the EII data. To learn more, go to ecointernet.asia. Do more, waste less.
Right. So that's the type of the research that we're doing, and looking at some of the case studies as well, and trying to develop some narrative. The index itself looks at the eco-friendliness of the different jurisdictions based on certain indexes. Again, it's of course it's not a complete like a complete accurate description of the carbon footprint of the internet, but it looks at different indexes and look at the comparative difference. One final thing that I want to touch on before I close is in the coming year, we're besides looking at expanding the number of jurisdictions and countries that we're looking at. Currently, it's at 14. We're hoping to expand it to 20 to 25 in the Asia Pacific region. We're also looking for partners, actually, maybe to take the same model, the same formula, and apply it to Europe, apply it to Africa and other places, and see, and expand the study a little bit further, so that we can have, a bit of a comparison. The last thing that I want to touch on in the coming year, actually, we're going to be focusing a little bit on this, is about a further case study on connectivity and also the what I guess related to some of the discussion you're having today, which is about data governance and data localization. So what we found is that our model slightly supports data localization, although we are revisiting some of that because, as you can see here, very interestingly, what we identified as part of the case study is that for New Zealand, which you see on the left, one of the challenges or one of the things that the study identified is that it actually has a lot of uses a lot of international bandwidth, and when we dig deeper, we saw that a lot of the services are actually provided by networks and systems in Australia. So whereas inside New Zealand, the renewable energy and all those kind of things for the network is actually quite good. One of the parts is about data. Actually, a lot of transit data is happening to Australia, and whether that's sustainable and whether that's good. Right now, I think we're undecided. The index itself slightly quote unquote punishes that behavior, but we understand that the internet needs to be global as well. So part of the work that we're looking at in terms of tweaking it is to how to think about that. So in the coming year, we're also looking for people who are interested to think through this problem with us. Because another very important aspect that we kind of support is that people a lot of times talk about data localization, and it really relates to digital sovereignty or national sovereignty, which is problematic because at Asia and a lot of the work that we do in terms of internet governance, we believe that more of a personal digital sovereignty is important. And how do we model that back into, and that relates a little bit to Jari mentioned, if we keep the data more radically local, not just to keep, data localization, often we talk about it in terms of localizing within a country or particular place. But what if it is localized all the way to the personal? Then the data transfer would be much less. In fact, that keeps the data transfer to the minimum, which is one of the things that we're interested in. So the transit shouldn't be an issue, but how do we add a component to look at or model how to minimize data is something that we're looking at in the next version of the index. With that, that's all I have. This is part of the work that we're doing, and hopefully this is interesting. And as mentioned, we are looking for collaborators, and we'll be excited to hear from you to see if we can work in other regions with the Eco Internet Index as well.
Thank you very much, Edmon, and a huge round of applause for Edmon. And it's it's good that you made all these bridges between the last talk and now that you're looking in global and local, otherwise known as glocal, that was talked about, and all these concepts as to how to limit the excessive sharing or traveling of data for environmental reasons. So we really appreciate that. Are there any questions online? I think there are no questions online at the moment. And we know you have a hard stop, so we we appreciate you being here with us. And the presentation will be on Descon YouTube channel, available after the live stream. Thank you so much, and have a lovely evening, the rest of the evening in Hong Kong. Bye-bye.
Thank you. Bye.
Okay, so we're going to have a lunch break now and come back here at 3 o'clock for the Internet of Things presentation and Đurđević and the panel session. And now the workshops are downstairs if anyone wants to join any during having their lunch. Second part of a second day of Descon 8.0. This afternoon, we will continue with our talks. Our workshop have now finalized, and the capture of the flag is still going on until the last minute at 1600. It's my great pleasure to invite, to see here Petar. Petar is someone who has been to Descon #1 as well. He's a founder of cryptoparty.rs. He's also an active member in 2 hackerspaces, Hack Club Belgrade and DZM. And he will talk to us today about IoT and security, especially looking at the open source tools that we have in security for this. So Petar, thank you for coming. Welcome. And the floor is yours.
So yeah, IoT security. As Des mentioned, in both hackerspaces here in Belgrade, we're doing workshops about security, and we mostly care about open source. So if you're using something like Windows, you come to the hackerspace, you will see that the majority of people use Linux and old hardware, trying to modify not just the operating system programs, but also the BIOS. And if you're interested in something like that, you can visit the hackerspace. What is IoT? Today, IoT is anything that is kind of smart. So any appliance that you can buy for home, like I don't know, light bulb or refrigerator, whatever, that has some kind of chip inside of it that you can interact with from your phone or from some applications online, and that this interaction goes through the internet. So if you have any questions during my presentation, raise a hand. So today, most of those appliances are, I'm going to talk about home, but you also have appliances that are IoT stuff that are for companies and not necessarily home. So critical infrastructure also has controllers that are managed remotely and that are connected to the internet. And as you can see, more and more stuff are connected, and those connections are going through probably your home router. So the internet speed of it comes in handy when you have more devices. Okay, intuitive. Yeah, okay. Many of those devices that we use today are cheap, and this pricing is really the drive that makes these technologies insecure, because many of the companies and startups that are making IoT stuff tend to make them as fast as possible, as many as possible, and as cheap as possible, so they can reach the wide range of people who are be able to afford them. So this means that they are compromising on security, because security of the IoT means you need engineer, you need some software, you need time testing it for vulnerabilities, for bugs, and the updates of those IoTs once they come to your home is also questionable. Once you buy something that is IoT, you basically never think about updating those software. You just put it and it runs, and while it works, you just leave it alone. So biggest flaw here is this fix, and that's why hackers are mostly counting on, and they are exploiting this. Maybe you heard about Shodan. Shodan is a search engine for not just the IoT stuff, but everything that's exposed on the internet. And they have search engine where you can search for, I don't know, cameras. That's most popular. And you can find cameras that are in your neighborhood or somewhere remotely, I don't know, Japan, I don't know, Turkey, whatever. And you can find all sorts of information about that connected devices. Like if we are speaking about cameras, you can find out Shodan what kind of firmware are they running, what kind of software versions. Is there any vulnerabilities related to those software? You can easily find all of this information from search engines like Shodan. But it's not only Shodan. Today we have a couple of more competitors in that space. So the information about insecure online IoT devices is available today to everyone. Just few clicks and you can find anything. You can easily find if your neighbor is running what kind of fridge if it's connected to the internet via IoT. So another negative stuff is that we don't have today many of the IoT security solutions. So if you go online and see what can you do for your IoT stuff at home, how can you secure them more? Is there some kind of company that is offering some kind of service or some kind of software for it? There is no. There's a couple of companies, but you probably not gonna use them because those companies are making their products for other companies, not home use. And the positive stuff is that the code that you're developing for IoT is very small. So if you are a hobbyist and you have a couple of other friends who are in security and know how to audit code, then you can ask them just to spend a few hours or days, try to test your code, find the vulnerabilities before you publish some stuff on GitHub and make it production ready. So easy to audit. Some of the software that we are using now, like Chrome browser or I don't know, Windows operating system, they have huge code base. So auditing those stuff is very hard, expensive, and takes many, many years. And when it's done, it's not 100%. They millions of lines of code. You cannot possibly see what is related to what situation can there be that you're not predicting. So one of the biggest attacks in IoT is that attackers are finding those devices and then using them to manipulate them to go to some other resource and try attacking them with the requests. So this is this is denial of service or dedicated denial of service, depending on how much of these devices are taken over by hackers. So once the hackers identify a vulnerable device, they'll try to find where else they can find the same device that they can hack. So for example, if they find some kind of vendor for a camera that has vulnerable software or firmware installed in it, they will try to find where else on the world is the same software also running. And once they identify them, they can also attack and hack all of those devices and instruct them to do whatever they want. So this is where they set up a command and control server. Command and control server acts like a server that it's telling those cameras what to do. In this example, there are cameras, but it can be whatever. And once the attacker tries to do for political reasons or whatever, he can knock out popular sites, and that's exactly what happened in the famous Mirai botnet attack. This is one of the largest at that point, and it really showed us what those small devices with internet connection can do when there are a lot of them controlled by a single threat actor. So Mirai botnet was actually pretty easy for hackers because they only needed to find out the default username and password for the device. So anyone who had cameras and DVRs of specific vendors and they didn't change those usernames and passwords, hackers easily identified within minutes on the internet when you connected those devices online and immediately taking them over. And they attacked some of the well-known hosting companies like OVH, and they taken out so many stuff that's on those hosting services. So hosting services are renting their servers, and you can have your own site there. So if you were on their servers, then this attack could disrupt you. But the scale of this is 1 terabyte per second. This is really, especially for 2016, really hard to defend against. And 600,000 devices is really not that small number. And for example, in Europe, the number of the IoT devices per person is like 2 or 3. But in America and Asia, this number is between 4 and 5. So, and growing. So this security is actually what we'll have to think about more seriously in near future for sure. Some of the popular websites were also down and unavailable in certain regions because of this attack, like Twitter, Netflix, Airbnb, GitHub, something that all of us actually use. And other stuff is ransomware. This is not that popular in IoT world, but it can also be affected because if you have some device that has some data on it that you rely on for functionality of this IoT device, that ransomware can disrupt it. But if you don't, you can just plug out and plug in, or turn off and turn on again device, and it will work pretty well again. Just in going back to Mirai, if you were attacked by Mirai botnet at 2006, all you had to do is to turn off the device, change the password, turn it back on, and it will be secure. There's nothing they could do. They didn't find vulnerability in the firmware. They just figure out the default username and password. That's all. So yeah, ransomware. Ransomware is more for devices that you use every day, like your phone, if you have servers or laptops, home computers, if you're gaming, that can be very disruptive if that happens to you. But for IoT, that's not that serious because they have chips that are going to default state to work if they are impacted. So not that for IoT, something that you should worry about. Another thing is this is a ransomware attack that attacked phone device. So from phone device, virus then try to see if you're connecting your phone to the smart TV. And once it saw the smart TV connected to your phone, it went to the smart TV and encrypted data on the drawer in the smart TV. So this can be actually something that you don't want to happen, but you can easily reset this to default and go back. This is just inconvenience because you maybe have some channels set up in order in certain way that you'll need to spend hour maybe setting them back on. But those attacks are now 10 years old. So we can see that these vulnerabilities in IoT are not going anywhere. Another security concern for IoT device is espionage, and this is also concern for the European Union and some countries in Europe that banned toys that have that are connected to the internet and have speakers and microphones. This is the famous case of my friend Kyla. And my friend Kyla was actually banned in Germany in 2017 because of these vulnerabilities. Hackers demonstrated that they can hack them over the internet and over the Bluetooth to serve ads and inappropriate content to the doll. Doll can also speak because children could ask something to the doll, and doll can answer based on data the doll finds online. So hackers can manipulate that to speak profanity or stuff like that, or loud noises to children, and that is major concern. So there is a good TED talk if you're interested in that. You can see TED talk Spies and Dolls, the future of IoT security. I think that's the talk from 2018 or something like that. Yeah, a couple of articles about that if you're interested. But that's basically what's happening. Trying to maybe European Union maybe try to regulate how secure your firmware or software on those IoT devices, especially for children. Another concern is that for espionage, as I said. So if you're some kind of senator or something in the government important, and you buy your children some of those toys that are IoT and connected to the internet, and go home and speak to your wife about something that's maybe confidential, and if hackers can hack your doll, then they can through the doll hear about your conversation. So another aspects of privacy. And there are some also solutions. First of the solution is this update stuff. So proposed solution for now is this firmware update over the air. So that means that once you connect your device and set it up, you don't need to care about this update. It will be done automatically by the device and the vendor that produced the device and the software. So you connect it, and the vendor updates it whether you like it or not. So they're pushing updates to hundreds and thousands of their devices when they have it, and that's nothing that you can do about it because you need to connect it to the internet. So once it's connected, it's gonna get the update by its own. You can read more about it if you're interested in that, but that's something that's not implemented yet in all of the IoT devices, but it's one of the solutions because the update is most critical, and end users in most cases don't know how to update manually their IoT devices. It's not for average user, and sometimes it requires some of the hacking skills. And the other alternative is also open source, because we are supporting open source. I think Climaeco has a lot of open source hardware in it. Yeah. So that's another alternative, because if you don't trust some other vendors from China or some other country, you can use open source stuff, and build your own code, compile your own code, and see, test your own device, how it works, and update it when you want, how you want. It should be a viable alternative. And another thing is, this is actually my kind of area, because I'm not that in IoT, but security. So this is how you can secure your own IoT devices and network at home using open source software and open source firmware. One of the devices that you all have home is ISP router. So you probably have Wi-Fi on it and devices are connected directly. Because there is no so much solution for this ISP router, my solution is to buy another router that I can flash some open source firmware on it and then make it do something that ISP's router cannot. And one of those things is installing and monitoring connections and implementing firewall rules and security inspections of the traffic going in and out, and also separating the networks from my devices that I trust and separating the network of the IoT device. So in case some of the IoT devices get infected, they cannot spread that infection and ransomware to my other devices that I trust. One of the solutions that here is implemented is OpenWRT. You can all see, and there is on their website, there is a list of supported devices. So not all devices are supported, but if you have popular device like Raspberry Pi, you can use that for sure for building your own home secure net. I'll just talk about some of the other open source security software that can be used and how it can be used and applied, and technologies that they implement to secure the network. So one of the things that you can do if you have maybe if you have older laptops and some old hardware at home PC stuff, you can turn it into a router. If you turn it into a router, then you can install some other software that are related to the network, like firewall. One of these is pfSense and one of these is OpenSense. They're both a fork of the same firewall router. And with that, you can do some pretty amazing stuff. For example, you can geo-block connections to and out of your network via IP reputation, and there is software called PF Blocker that can do that. So you can specify the policy, say never go to the addresses in country X, Y, and Z. So when they hack some of the stuff you have, they cannot attack some other countries, or the attacker cannot come from those countries. Another is DNS. You can just, this is much easier. You can just use some of the free available DNS solutions that are automatically implementing and dropping packets for the known attacker. So, for example, we know that xyz.xyz is an attacker. DNS will not allow you to go there. So if any of your device is infected, it will be automatically, packets to this domain or IP address will be blocked. Another solution is Snort or Suricata. This is IPS and IDS solution that are both open source and do fantastic, even in production environments and in big companies they are used. Snort is developed by Cisco, so this is their open source project, and it works very well. What it does is actually inspect the packets that are coming in, going out, and you can say, you can download the rules, apply the rules, install the software, and they will see if there's some kind of attacks is happening. If someone is trying to abuse SQL on your network, so trying SQL and attacks and stuff, other stuff like that, Snort can recognize those attacks based on their rules for the packets on the network coming in and out, and drop them. Allows also, we talked about separation of networks. This separation can be done by firewall or VLANs. Sorry. So basically, you can set up two different Wi-Fi networks for one group of device and another. Most of the routers that you have from ISP can set up two Wi-Fi networks. So one for you, one for your home, and like second is guest Wi-Fi. And when guests come to your network, you give them this isolated guest Wi-Fi, not to interact with your own. But with the open source software, mainly PFS and also OpenWRT can do that. You can set up as many as 8, for example. In newer devices, you can set up 8 different Wi-Fi networks on your network, and separate those devices based on trust, based on how secure you think they are, and stuff like that. And this also prevents spread of infection when it happens. This is very, very good. Quality of service is another good way to thwart attacks, so to say. So once you have IT in your home, when attackers compromise it, they will try to attack some other website, and that will generate a lot of traffic. So you can, with QoS, you can limit how much each device on network can use bandwidth. So if you can monitor it for a couple of days and see that your, I don't know, fridge used 1 megabyte of data per day. You can set that limit for each device or each network that you separate. And you can use some other open source project like Pi-hole. This is now well known and well tested. You can use any Raspberry Pi and turn it into a secure DNS. Basically having your own alternatives to those services that you can use for free if you want. There are some other projects that are used not specifically for IoT, but that they have IoT application as well for detecting suspicious activity. I don't know how to pronounce this, so I'll leave it to you. But it can map the data, and you can see what device communicates with what. So this can be useful to see not just devices that are communicating with each other, but the volume as well. And based on that, you can find attackers if they're on your network. Something suspicious is happening. Basically, all 3 of those projects are based on gathering information about network activities and analyzing it and presenting it in a graphical way so you can visually see what's happening. And the last thing is this remote attestation. This means that once you set up your first time you turn on your IoT device, you can install this Keyline. Keyline is a software that will check if the firmware and software installed on IoT device changes. So every time it reboots, it will check for the known good configuration and compare it to the ones that it first time scans. So what this prevents, for example, a hacker can, if they hack your device, not just change your password, but they can maybe upload some other firmware on it that they developed or stuff like that to give them persistence on your device. So when you turn it on and off, they will probably off your device. But they can install something to be persistence on it, even if you turn it on and off again. So this Keyline will check each time the device boots if there is any changes in software installed and configuration. And if there is a change compared to the last known good configuration, you can specify action. Action can be isolate device or don't let it run, turn it off, whatever. So this can be detection and prevention measure for IoT. I think that's all. I can show you my network. This is how I secure my network with lots of routers and stuff. But it doesn't have to be this complicated for you, because you can use Wi-Fi networks for most of it. And I'll also invite everyone who has some ideas in security, especially in IoT, to talk to me if you want. There are some products that do this, but I don't want to market companies that don't use open source. Any questions?
Who's first?
So thank you for the presentation. And two short questions. What about IPv6? Is it prevalent in IoT devices? And is that an issue in itself? And the second one, I heard the worst IoT device you can have in your home is the Wi-Fi extender that can actually grant access to hackers to your home network. So do you have an experience with that?
The first question is IPv6, and I think if I have experience with using this open source firewall, pfSense, and the security for this is exactly the same for IPv6 and IPv4. Whatever you choose to use and the configurations are the same. So same security plugins that you install and services that you use on pfSense apply for both. So, for example, I talked about this. So I talked about this snort and suricata for intrusion detection. It works the same if you're using IPv6 and IPv4. It doesn't really matter. I'm guessing the same goes for DNS, but I don't have many other experience with IPv6 for now because my network is not that big. This is it. And the second question was
Wi-Fi extenders, the things you.
Yes, the Wi-Fi extenders have the same problem as any IoT device. That the default credentials. The users often don't change them because they don't want to deal with thousands of passwords. So this is the thing that people can exploit. And also the same goes for updates. They don't update themselves automatically, and probably the users are not doing that as well because
I also have two questions to ask. The first one is related to the attack surface. So let's say I have a cheap Wi-Fi enabled camera, 20 euros, and it runs on embedded Linux. So is that considered something that can be audited in a short amount of time, or it's actually, again, millions of codes as with Windows? That's the first question. Second question is, again, for that cheap product, what is the, can you explain us a bit more how the IoT device or camera in this sense, which is connected to our private network, how it is visible from public internet? So what's the scenario? How will the packet reach it if it's, I don't know, behind a basic firewall from ISP router?
Yeah. If you have any kind of firewall or not, it won't be reachable unless you explicitly have firewall rule that says expose this device on this port. No chance that anyone can see them if you don't let them. So most cases, the cameras that are hacked are internet cameras that are directly exposed to the internet.
Okay, that's understood, because main home, the bulk of the home users have one dynamic public IP, they're lucky, and everything on their network is in private IP space.
Yes.
So I don't see the scenario. Maybe I missed something. That's why I ask.
I think those users are fine if they are behind the NAT. This is called NAT when they have their private IP network behind the router. So if they cannot reach their router or camera from the internet, that they're safe. And they can also use this shutdown kind of thing to find. They can go to what's my IP address, find their IP address, and put this IP address in search engines like Shodan and see what others can see about them. So
understood.
That can be a preventive measure as well. They can see what attackers see, and they can be sure that there is nothing to worry about, or there is something.
And also the first question about the attack surface and Linux and millions of code.
I tried to find, but I didn't because this is not something that I do. There should be at least one framework that analyzes the firmware. I know because I was interested in this topic a couple of months ago, but I didn't bookmark it. And there is a framework that analyzes firmware from routers. So if you have some kind of proprietary router from your ISP, you can dump the firmware and analyze it. So there should be something like that for other firmwares as well. I don't know now the correct exact name, but I think you can search on GitHub.
Yeah, I know about the manual process to unpack the firmware and analyze it, but it's interesting to do it automatically and by some suit, which can analyze it in depth.
Thank you. A nice presentation. I would like to ask you, do you have some tools for scanning the security, for assessing the security of IoT devices? For example, like Burr Pro or Arckinetics in web applications or Nmap for servers, etc. Can you use Nmap, for example?
I think you can use Nmap, but there are other open source projects, I think like Nessus, stuff like that. You can use it, run it locally and scan your own network internally from some of your own devices. That can do a trick, but I don't know for any specific software that does this for IoT. Those are all general scanners that try to find the vulnerabilities in servers and every other exposed web application, stuff like that.
Thank you.
If there's no more questions, we'd really like to thank Petar with a huge round of applause. And come back anytime. Our next presenter is one of our, I guess, best climatologists that we have, and we're very lucky to have him here today speaking about the digital atlas of Serbia, which is going to be connected again in the panel discussion later on. And I believe the slides are ready. And so yes, Professor Vladimir Đurđević.
Thank you. Thank you. Okay, I will give you a presentation about this digital climate atlas of Serbia. It's atlas and it's digital. And next slide. Okay, it's online tool. It's interactive and it's for you. It's available to use anytime you like to understand how the climate was changed in Serbia for the last about 70 years, and also to see the projections of the future, to see how the climate is going to look like in the future. Okay, and this is the landing page to the atlas. So you have these 4 main, let's say, data sets, and then you have here some menus in which you can pick up what you want. So there is 4 variables and 22 climate indexes. When I said variables, it's temperature and precipitation and things like that. But the climate indexes are derived variables from that essential, as it call it, like a number of summer days. So the summer days is the day when the temperature is above 25 degrees. So you have index, which is measure how much of summer days you have during 1 year. So you can have time series how this number is changed into the future. So in total, you have like a 26 different numbers that you can explore, and you can explore numbers for the whole of Serbia, for these regions that you can see now, for municipalities, and for single points on the map. So you can choose your point and see how this variable is changing in that point. There is the time period that is covered is from 1950 to 2100, and there is 2 scenarios of the future. So you have scenario in which people doing zero about the climate change, continuing to emit CO2 into the future, and there is another scenario that we call it mitigation scenario. So it is scenario in which people in one moment stops to emit CO2 and stabilize climate system. There is different seasons like summer, spring, etc. And there is a 4 level of spatial analysis. So as I told you, there is you can calculate something over the whole territory, then over the region, over the municipality, and over a point of interest. And also, if you click on the map, you can see this time series of variable that you want. This variable here is growing season. It's part of the year when plants are active on surface. And all that you can see on the atlas, you can download as a figure, or you can download it as a data. So all data is free available to be downloaded and use it without any kind of registration and any kind of verification for what purpose you're going to use the data, etc. So all data is open to be used by anyone who is interested to use the data. The atlas is developed under the project with a really long name. It's funded by Green Climate Fund and implemented by UNDP in Serbia, and it's developed by Faculty of Physics, on which I work as a professor, and the Neopix company from Niš, and it's hosted on this web address atlasklimaeco.gov.rs. It's hosted by Ministry of Environmental Protection. So why we first created this atlas? The main idea was to support adaptation process to climate change in Serbia. So if you build a bridge in some city, you want to build a bridge which is going to be resilient to the future floods, not only the current floods, because we know that we have this positive trend of extreme precipitation. We have stronger and stronger precipitation for the last 70 years, and we're going to have stronger precipitation in the future. So if you want to build a bridge in some city, you don't want to build a bridge which is resilient to current precipitation and current floods, but you want to build a bridge that's going to be resilient to the future precipitation change and future floods. So if you sit in that municipality, you want to have the data how the precipitation is going to change into the future, and to create your spatial plans, bridges, everything to be more resilient. And it is called adaptation to climate change. So how you're going to adapt to face lower level of problems into the future. So the main idea is to have the data that is available for everybody who needs to plan the future and to make that future more safer in terms of climate change. And that was the main idea why the ministry built this atlas, but we also try to implement other ideas that can be, let's say, that we expand these potential beneficiaries of this atlas. For example, you can use atlas for education. You can see how the climate is changing in current moment and how it's going to change into the future. So it can be interesting to educate people about the climate change. Then for professional decision makers or companies that can consult somebody what to do into the future. So you can create, let's say, small engineering company who can advise agriculture producers how the climate is going to change in the future and how they can change their practices in terms of this agricultural calendar during the year, etc. And you can sell, of course, that information, but the background information is freely available, and you can use that information from this atlas. And also the atlas can be used for this, which is public communication, because climate change is really huge problem, and you really need to have a lot of people on board to, let's say, solve it. And the public communication about the climate is very important. The people need to know that something is happening, is going to be worse, and that there is a chance that we can stop that in the future if we act on time. Also, there is other ideas behind the atlas. Some of them are also presented. We want it to be simple. So you have a lot of other atlases, digital atlases online, like IPCC Atlas, which is global, and then you have this Copernicus Atlas, but both of them are more designed for professionals or semi-professionals. So you need to know something about the climate models, climate change, etc., to be comfort with that. But we wanted to have tool for which you don't need so much background knowledge to navigate through the data, and also we wanted to have all the data available to all people, but also for professionals, we made a special page on which you can download the whole data set and then operate over the data. So you don't need to browse through the atlas and to change pages and variables, but you can go to one page, download everything, and then you can process what you like. So in that sense, on the atlas, you have limited number of options, but we think that all options are there because we want to clearly communicate this climate message. You will see at the end what is the climate message for Serbia. So the atlas is designed that somebody who uses atlas will easily pick up this main message for Serbia. The background data is produced or downloaded from Copernicus, let's say, system, and observed data relies on this EOPS grid climatology and the projections coming from this Eurocortex data. So we didn't produce any of data on the atlas, but just customize the data for Serbia. And the reason why we do that, because if you want to do what we've done here, you need to download about 60 terabytes of data, and the total volume for the atlas is half of terabyte. So if you want to pick up one point over Serbia and calculate how extreme precipitations is going to change in the future, probably you will not need to download 60 terabytes of data, but probably you will need to download something like a few terabytes of data, and then you will have just one figure how the precipitation is going to change. It will be very small. It will be like a kilobytes. So the idea is that we use this huge volume of data that we have in the background, and then we customize the data for the users in Serbia, so we don't need to reprocess every time that big volume of data to have local information. And that's the point when we talk about this minimum sustainable data sets. So we try to reduce the amount of information that is really needed over the Serbia. And when we done that for once in a time, then everybody can use that minimum data set and to reprocess it many times more. So we done a job for many other people not to do and just to use our results. And to demonstrate you this kind of how to call it paradox in world of climatology, I will give you a story about this figure. Okay, this is the main figure for global negotiation, political negotiation about the climate change. And this figure is a figure about the global temperature of Earth, mean global temperature. The black line is historical temperature from the 1950s up to now. So the black line is history. And these colored lines are future scenarios, how much the Earth is going to warm up into the future. Okay, so one of the scenarios said you can expect 1 degree more warmer world by the end of this century. And another scenario tell you it can be like a 5 degrees warmer. Okay, and this planet which is 5 degrees warmer, it's almost uninhabitable. Okay, it's really different planet. It's a planet with a lot of problems. Okay, and this planet here also has a problems, but the problems that can be controlled. Let's say we can adapt to this, and it's really hard to adapt to this here. So when you have a global negotiation, what the all nations around the world is going to do about the climate change, they'll look in this figure here and decide which future they're going to pick up. Are we going to pick up this future or this future? Okay. And officially the world pick up this future, but in real life we pick up something between. Okay. But this is the main figure how we negotiate about the future of the Earth. And this figure, the size of the figure is about 200 kilobytes, but the data behind this figure is 3 petabytes. So climatologists need to produce like a 3 petabytes of data to give you this figure, and then you should negotiate about this figure. Okay. So it's really interesting how much of information we really produce to come to the moment in which we're going to decide what we're going to do using just simple colored lines. Okay. And one of the idea in the climatology is to try to understand how to produce as much as possible small volumes and to have reliable information on which we're going to negotiate. Because currently we really use a huge amount of processing time and silos of hard drives, etc. These big climate centers have these super big supercomputers of hundreds of thousands of processors, etc., to produce all this information. So in our story about the climate atlas, it's not story about this figure, but it's story how you try to reduce your volume size of the data to the data set, which can be useful for a lot of people, and in that sense to keep information as smaller as possible in terms of kilobytes, megabytes, etc. As I told you, there is 4 levels of this data analysis, and that's the point again about the data volume. So if somebody wants to pick up grid point here, if he starts from the beginning, he will download like 10 terabytes of data, and he will process all that data and get the information here. And if everybody, municipality in Serbia do the same things, then the Serbia will download like 200 times of 6 terabytes of data. And because we don't want to that happened, we downloaded 60 terabytes of data for the whole Serbia, prepared data for each municipality, and from that moment, each municipality will have information for their cells, and that information can be just one Excel file with 2 columns with temperature and date or year or something. There is also the page on which you can learn what is the climate indexes, what are scenarios, what are climate models, and there is also a page with the file names, because we decide to have this kind of file naming convention. So when you download the file, you know what is inside the file without any metadata about the file. The files itself has a metadata inside the file because the format of the file is with the metadata, with the header. The format is netcdf, but also the name of file is already metadata. So if you learn how the letters and acronyms are put it in the name, you easily understand what is inside the file. And this is also one interesting thing, because there is a lot of maps with the colors. We use these color bars which are colorblind safe, because some people are not capable to see different shades of same color. But you can choose color in that way that everybody can see all shades. And if you learn what are shades and how are defined, they are you can find it in the metadata of the file. So if you scan this netcdf file, you will see each color for that map. What is the color of that shades? And this is the main message. Who is interested in future climate is Serbia. I told you one of the ideas was that Atlas give you the main message how the future climate will look like in Serbia. We had a really hot summer this year, and if you think it is hot, it's not hot, it's going to be hotter. So looking into the heat waves, we can expect increase in heat waves in terms of frequency and intensity of heat waves. Here we can also expect increase in temperature. We can expect a decrease in summer precipitation. We also had a strong drought this year, and this trend of the summer droughts will extend into the future. So in the future, we can expect more droughts like this one and stronger ones. But on the other side, we can expect more extreme precipitation in the future. So we also should think about the floods, not only the droughts, and it's complicated. And here is the frequency of drought. This is the frequency of the amount of precipitation. This is the frequency of drought. And it's interesting that on annual level, we will have more or less the same amount of precipitation. The total amount of precipitation will not change into the future, but what's going to happen, you will have like a long periods of dry weather, and then in a short time period, you will have all precipitation that you skipped in past few months. So you will have drought, and then you will have a risk of flooding. Okay, and that's the story about Digital Climate Atlas. Probably it's a new topic for you, so it will be great to have questions from your side to understand how you see this tool and this job.
My name is Nicola. Do you already have someone interested in data? Or also yeah, do you hear me well? Okay, so do you have any users of the data, or applications or institutions using this data?
Yeah. Researchers are much more familiar with this kind of tools and data, etc. So we already have like I'm not sure the number, but probably more than 5 and less than 10 published scientific paper which rely on this data set. We also have people from municipalities, which should be like main users of this, that are interested in this tool. Currently, by the law, the municipalities are not, from them are not expected to understand future risk. So each municipality should have some kind of risk map for municipality by law in Serbia. And they created this risk map using only data from the past, how the climate was in the past. I mean, the risk map related to the floods, droughts, wildfires, etc. And there is no law which tell them, okay, you need to calculate also the future risk. But that law probably will be adopted in next year or two. In that moment, the people in municipality probably will be forwarded to this website to calculate the risk of the future. So currently, people in some municipalities like Kraljevo, it's very advanced municipality in terms of understanding these natural hazard risks. They already use this atlas to try to calculate risk into the future, but probably in one moment, many of them will do that. Also, I know that in some schools, teachers use this atlas to explain to the kids how the temperature will change and how it's going to change in the future, etc. So we don't have any kind currently. We don't have any kind of official statistics about how many people use atlas and how many users we have in this moment. But from this, let's say, some common experience, we know that people using it.
And how precise is the data when you look into the future? So, for example, the next year, is it precise that you can have?
It's not that kind of calculation. So when I tell you that I know the future climate, I don't know how the next year is going to look like, or 5 years from now. But I know that into the next year, there is a range in which you can expect your climate. Okay, so we have this kind of uncertainties calculation, and that's the reason why we have this 60 terabytes of data on the beginning. So you have a lot of integrations in future, and from that lot of great number of integrations, you calculate your uncertainty range in which you can expect that temperature is going to be in next 5 years or next 10 years. So I cannot tell you the next year is going to be hotter by 2.3 degrees, but I can tell you that next 10 years, the temperature will increase about 0.5 degrees, and the uncertainty range will be from 0.4 to 0.8 or something like that. Okay, and that's how the climatologists present the future to others. You can see here, each line has this uncertainty range. Okay, and that's the reason why there is a 3 petabytes of data. So you have a numerical model that simulates the Earth, and then you create like a 1,000 futures. Okay, and from that 1,000 futures on Earth, you calculate your uncertainty range, and then you tell that median of that uncertainty is going to be most probable future.
Great, thank you.
Just a question, like, but that calculation, it's not currently made on the website, right?
No,
It's
no,
something
no,
that is expected
no.
that you do it on the municipality level.
No,
Yeah, and then like each year, will you update
No, we're
the
gonna
measurement
update. No,
from the last year?
probably we're gonna update the atlas every 5 years. Okay, because there is a two services that climatologists produced. One, we call it operational services. It means that every month you tell the people how the month was, how much it was warmer in comparison to the past, how much precipitation we have last month in comparison to past, etc. So we call it operational services. And for operational services, the institution which is in charge in Serbia is Hydromet Service, okay? And this atlas is more like a future plan, risk, etc. So you can update that information every 5 years. And it's not important to have update every month what's happened, okay? So we look in this long range projections of the future and try to understand that future in the middle of this century, by the end of this century, etc. And what we done for this atlas, it's super fast. If you try it, you will see that when you click on variable, you will have map in a second. And the reason why it's like that is because we really calculated everything which is displayed on the atlas. So for each grid point, for each variable, you have one file for that. So at the end, we create something like a few thousands of maps and like something like 140,000 of Excel files, I think, and everything that is on server ready for you. Okay, so the server will not calculate anything. You will just pick up your variables and the file is already there for you. So it's one time huge calculation, and after that everybody will have that in a second. That was our idea, how to avoid that kind of, because many of these atlases have this kind of philosophy. You have background data, you ask for something, and then servers start to calculate that for you, and then you wait. Then you wait some time, and then you have a map. And then if you have 100 users, you will have 100 calculations of server, and maybe you will have some kind of slow response, etc. So we try to avoid that, to calculate everything in for once, and from that moment, everybody will be able to access the information very fast and very efficient.
Hello. Maybe this question is not related to this. I heard on a similar panel that Serbian thermoelectric capacity is 3% of Europe's, and that we generate 30% of harmful gases or particles. Is this correct? And can you tell us something more about it?
Probably. Because we are small emitters in comparison to other countries. Okay. There is different way how you can compare countries about emissions. Okay. One way of comparing countries is to compare this total emission of the whole country. Okay. But you can also compare how much country emit per person. Okay. In that sense, we emit, like each person in Serbia annually emit about 4 tons of CO2. Okay. And United States, average person emits something like 16 tons per CO2, because we call that they are more energy intensive. Okay, because they have bigger cars, they have more IoTs in buildings, they have bigger buildings, they have bigger air conditionings, etc. Okay, so in that sense, Serbia is somewhere in the middle of the world emitters. Okay, comparing the total emission of USA and Serbia, it's not comparable. We are like 0 point something of United States, but in terms how much person produce for 1 year, we are not that small. We are not few percent of comparing to person of in United States. But there is some countries in Africa in which, on personal level, there are few percent. There are few tenths of percent of United States. They emit like a half ton of CO2 per year. And for me, maybe the most, let's say, honest way, how it's not most honest, it's second most honest way is to compare how much you emit per unit of GDP. Okay, so it tells you how you energy efficient. And in that sense, Serbia is not good. We emit like a few times more CO2 for GDP unit in comparison to European countries. So that means that we are using our energy very inefficient. Okay, so we are dropping energy and emissions without caring what we done because we produce this energy. So we produce much more energy, and we don't have any kind of benefit from that energy. We just spilling out. But and the most important and most how to say comparison about the countries is historical emissions. Okay, so how much you emitted from the middle of 19th century? Why? Because the CO2 that is emitted in the middle of 19th century is still in the atmosphere. Okay, so what is count in this moment is not how much we emit right now, but how much we emitted in the past. And if we compare that, the United States is really on the top, and Serbia, it's again somewhere in the middle in the world. But the biggest polluters in that historical emissions are United States, China, starting to become closer, but also countries in Europe like Germany, like Great Britain, etc. So they're big historical emissions. And there is also something which is called carbon budget. It's like how much you are allowed to emit into the future to stay under the Paris Agreement. Okay, and in that sense, we have the amount of CO2 that we can emit in next 30 years, and that amount can be divided by countries. And if we really want to be fair to countries in Africa, Serbia and other European countries should stop emit very soon, like in next few years, but it's not going to happen. So the climate justice is complicated problem. It's not just how much I emit right now, but also it's how much I emitted in the past, how much benefits I have from that emission, how much my economy growth because of that emission, etc. So it's not only the question how much we are emit currently right now as a whole country, especially.
Thank you very much.
Hi, hello. Anna is my name. I'm a digital communicologist and a runner as well. So last evening I went for a run, and I wanted to use the opportunity to ask you as a meteorologist just to explain to us where this toxic rain, or I don't know how to explain it. My glasses were completely dirty from the rainfall. So is there something that you can like? I don't remember, like, yeah, in Belgrade, like last night. I don't remember last time or if I've ever experienced such. I would say it's prljava kiša. I don't know. Yeah,
Okay.
yeah. I don't know
Maybe-
if there's an
yeah.
English expression for this, but thank you.
Okay.
Acid rain.
Acid
yeah,
rain,
Thank you.
yeah.
I think it was this. Yeah.
It can be solution or it can be dust from Sahara in Africa. Okay, so we can check. I can check later the website and to see is there any dust from Sahara in air in the last 2 days here. If there is some dust from Sahara, then you probably had that dust on your glasses.
Okay, but is historically, like, if you look
happened.
at retrospectively, like, would you say that it's more prevalent now than it was
No,
10 years ago? Or
no,
20?
no, no, no.
Like, is it
It's-
something that
I mean,
reoccurs, or
yeah, yeah.
like,
In Serbia, you have, I mean, at least one per month. You have situation that you have Saharan dust in air, and then you have rain, and you have deposition of that dust on surfaces. It's not more common in comparison to the past. Maybe there is some changes, but not such a big changes. The situation when you have this prolonged period of hot weather in Serbia, like we had in last 1 month, it means that you have a lot of African air coming in this area. Okay, so from North Africa, that's the reason. It's not possible to have such a high temperature without having very hot air from Africa coming here. So we had this coming of air from Africa for a weeks, and also in the last few days we probably have some kind of additional air before this raining episode. So probably there was some dust because during the summer we don't have this winter pollution in air. We have other pollution, which is ozone, and you cannot deposit ozone. So it's not pollution on your glasses. It's probably the dust, but I will check it for you.
if I may just say thank you so much for getting this data from Copernicus and making it easy for us at the hackathon to actually play with it, because it saved us downloading 50 terabytes to 0.5 terabytes. So it's already a minimum data set. Also, having heard what you said, that the weather is going to change, the pattern, that we'll have more precipitation in smaller time frames within a year.
Yeah.
Are we actually becoming East Asia?
Yeah, maybe something like that. Especially during the summer. Yeah, it can be something like that. Like to have like several weeks of nothing, and then you have, and also what we had this summer, you have like let's call it nice weather, but it was really hot weather. Okay, then you have a little bit of rain, and then you have a lot of humidity in air. After that, a little bit of rain. You don't have like a real rain, and then some kind of relaxing, better temperature, cooler temperature, etc. But you had like a lower temperature for 2 degrees, and then we are on a 40, then we have 38, and a little bit of rain, and then you have huge amount of humidity in air, which is then additional complication for everyday life. So in that sense, we're starting to look like something like Southeastern Asia, at least for a few days during the year.
Well, with that, if there's no more questions, let's give a huge round of applause to we have a 5 or 10 minutes break before the panel is here, and Professor Đurđević will be on a panel. So let's have a 5-minute physical stop. So good afternoon, everyone, again, and welcome to our panel this afternoon. It will be in English, but we can also do it in Serbian if the audience wishes us to switch. But bearing in mind we have some international guests, perhaps we keep it in English. Yes, it's a great pleasure to have this set of experts here at Descon. It's a real privilege to have all these panelists joining us this afternoon, and I'll introduce one by the other. But to say first a couple words about the panel. The panel is about citizen science. It's about empowering citizens with technology, and the technology is out there. But there are still many, many questions open with regards to data, how citizens get involved, what does it mean to us, that we will try to answer for you this afternoon, and feel free to join because it's more of a workshop. So Professor Vladimir Đurđević, you have already met just earlier on, our climatologist and a professor at the University of Physics in Belgrade. He spoke about this digital atlas of Serbia that we are thankful to him because this datathon was going to use some of the data to use with our network. Then we have Vladimir Trkulja joining us. Thank you, Vladimir. He's an innovation expert and a consultant involved in many, many projects, starting with the first original started in Belgrade, an advisor to international organizations as well, like UNICEF. And then we have Dr. Primarius Elizabeth Paunovic, who spent a lot of time working at the World Health Organization. So she's an expert to the topic that we cover usually at Descons, and that is air pollution and how it contributes to climate change. And then the last, not the least, is Obrad Vučković, with the nucleus, with the research center the Nuclear Research Center of Vinča, but you're actually a librarian and a head of library and an expert on open source. And as you know, also our network is all open source and open hardware that Descon community is running. So I think without, with you know, these different angles that we might have here at this panel of how technology is helping citizens get involved and what is that relationship. Maybe I'll start with a question to each of the panelists, perhaps to say, what are you doing in your research area? What are you noticing that is relevant to air pollution and the environment? How do you access the data that you in your research work today? So we start from that angle.
Okay, maybe me or maybe we can go from there because I've been.
Get some breath.
Is this on? Yes. Okay. Okay. Thank you. I'm from, like I said, from Vinča Institute of Nuclear Sciences, that is also member of University of Belgrade, and yeah, I represent actually one community, a small but important one, from and growing, community of and open science enthusiasts. And we are working a lot of promoting open science and its principles and activities. Open science is, as you know, like umbrella term. There are a lot of things included in open science, like open access, which is maybe the most most people heard of it because it's it involves in making research results like research papers and conference proceedings and so on openly and publicly available, and with open licenses, which means that there are usually usage terms in which those documents can be used. But also, it's not open science is not just about open access. It's about open data, which I think it's most important here for this conference. It's about open data that is are data that are freely and openly available with license agreements, and about open software and also open infrastructures. It is very important. And there are a lot of other open aspects. I urge you to read more about open science, but especially one thing that is not open in its name, and it is citizen science. And that is something that is quite a new topic here. And I will talk more about it later. There are one interesting project now here in Serbia by University Library concerning that. And librarians are playing more and more important role in open science movement, and that is why I, as a librarian, am in this open science community in Serbia.
Thank you. Thank you very much for inviting me. I will comment from the point of view of my expertise, environmental health and environmental protection. I would say that with the era of digitalization and accessibility of data, it was a huge kind of a revolution in this area. We have numerous international agreements and at the country levels laws, and Serbia is party to these conventions that make are requiring that all these data that are presenting the quality of the environment or the environmental impacts on health are open source, openly accessible to all the citizens. And this was made possible really by the development of digitalization, because these complicated algorithms and also epidemiological researches and the knowledge on the impacts of the environment on human health, in fact, got a special level, higher level of quality, because it was possible to include millions of individuals. So it was possible then to make conclusions how polluted air, for example, is impacting human health. And even nowadays, which is now already known for 20 plus years, in public is not so well known. For example, that polluted air is the main cause of cardiovascular disease, of diabetes, for example, that there is no single organ that is impacted by air pollution, especially by the small particles, PM2.5, that are entering our body through the lungs, to the bloodstream, and then depositing in all the organs. So by that, when we are talking about data, accessibility of data, immediate benefit of this online accessibility, especially when we are talking about the air pollution, but also water quality, is that we can prevent harder damages for health by informing public and taking necessary actions, in fact, to prevent this. It should go immediately, public alert, don't go out, or for the groups that are especially sensitive. We can see that it's not functioning quite well in Serbia, but more and more is functioning also thanks to these citizen science devices from your projects, because still we don't have air quality monitoring in all the cities in Serbia. I would say, for example, Leskovac. It's not a small town. If we were not having citizen science personal devices, we wouldn't have any data, or we will have very, very limited data, or no data in real time data. And I will mention then the other, in this first comment, the other benefit, in addition to this immediate benefit, which is really clearly visible now, that we can act upon the warning when we get this data, is that they can be really used for the purpose of policy making and for giving the politicians the right way forward in making decisions in the area of environmental protection and protection of human health from environmental impacts, because there are numerous evidences now that they can use, and they can also through this policy development process request answers to specific questions. Which is the biggest problem at a certain point? What should be done? Which are the most appropriate measures? Who is the most sensitive? What to do to protect the most sensitive parts of the population, and so on. So these two benefits are extremely important, and unfortunately, I have to say that we say it's a new area. I mean, it's 25 plus years developing, but we don't have enough experts in our institutes of public health to deal with the environmental risk assessment. And this is one of the problems that should be addressed in the future in order to use all this data. I mean, we are now having huge amount of data, but the results and the knowledge about the impacts are very, very, very limited. And we are measuring in order to get the information of the impacts, not to know. In one local municipality, I had one round table like this one, and they told me, look, doctor, we don't know, what does that mean that it is PM is annual mean level is 40 micrograms per cubic meter. Is this dangerous? Are we going to die? Are we going to die sooner? Who is going to die? And what is this? So this is one of these parts of the puzzle that is at the moment missing in Serbia.
So thank you, Elizabeth. I'll just ask you, where do you think that the citizens should get the data? They should be open. There is a
yes,
law
of course.
saying that it should be open, but where are they getting it? You said that there's a lack of data.
There is a lack of risk assessment data.
Risk assessment
so
data.
Environmental quality data we can get from the website of our Serbian Environmental Protection Agency, and this is opened. We
But
have
it's not
applications. They are not real time. Some institutes of public health are having real time. We have a application Eco Extrema. I'm sorry that Mr. Lekic was not able to attend, but this application for our phones, or we could go online, is pulling this in a real time.
And this is not government.
This is not governmental, but it is citizen science.
Absolutely. We provide him with
Exactly.
our data. And
Exactly.
unfortunately, he's not in town.
He is, in fact, collecting all the data from Environmental Protection Agency because they are accessible online, but not for the citizens in that respect. So he made this click for the citizens.
So there is way to get this data with the help of citizens.
Exactly.
network.
Otherwise, we get the report just 2 days ago. The report for 2023 on air quality was published, and then tables and everything. But again, we don't have health impact assessment, risk assessment.
Risk assessment. And maybe, Vladimir, you are somebody who is maybe part of this network, Citizen Science Network. You can tell us, what do you see yourself? What is your role as this volunteer in the Citizen Network measurement?
Yeah, so I'm obviously not a researcher in a domain of environment, but I can comment. So I mean, in the domain of ecology or like environmental protection, as a citizen, you know, like my needs go in a direction. How should I know if I should take my kid outside for a walk? And when the concentration of pollen in the air is high enough that I need to start taking meds so that I could actually breathe. So like I mean, for this first thing, before getting kids, you know, like it was usually you either ignore the fact about the air quality, or you just go out and try to smell the air. And it was usually working well in Belgrade, like in the winter months. But like after Klimerko project, because I participated in making as a participant in assembling Klimerko device, you know, like I have one of on my terrace, and I just like usually take a look at the data from it, and you know, then you make like sort of a educated guess, should you go outside or not. And that's how I use like the data that I'm like sort of personally gathering. But you know, like that, I think that a lot of that has been done in the last years, and nowadays, you know, like even having like environmental data on news portals, that's something that was not happening like, I don't know, 5 years ago. Yeah, not even 2. But now it's like, you know, like I mean, it's like sort of an irony, you know, like a few years ago, if you would like, maybe it's still happening, I don't know, like if you would watch the main informational broadcast of the national television, you would have like a weather forecast. And during the winter months, you know, like they would go, oh, it's a beautiful December day in Belgrade, you know, like take your kids to Kalemegdan, you know, like, and like the air quality is in red. So like you have like the direct suggestion from the national TV saying you to go and like expose yourself and your children to the air quality, which could potentially like yet to be proven, like, you know, at which pace you could, you know, like kill yourself and your kids. So So yeah, that's one of the ways that I sort of solved the like or gather data. And this other one about the pollen concentration, I still have a habit of from time to time going to the national agency SEPA and just checking this, I don't know the word in English, but it's ambrosia, because it really affects me. And because of the climate change now, it's like it's starting to the pollen starts to spread earlier. So like it's not like, oh, it's like end of August, early September. Now it's much earlier. So like knowing when to actually start taking the meds is pretty important. Ragweed, my favorite plant. Yeah, I should know its name. So yeah, I just get that data, start using meds, and that's how I use it. That's like from the citizen level. That's like some real use cases of the data. Could it be more user friendly? I mean, obviously yes. So like to access my numerical data, you have to log into a proprietary system and find my device, or like save a web page and take a look at it. And it would be really great if I could get notification of like by SMS or something like that for the ragweed pollen concentration. But that's something that I think people hopefully are already working on, or that's some of the ideas how this can improve.
Yes, thank you for sharing with us your experience, and a painful experience, I would say. It's not a pleasant one, because we are certain that the quality of air has fallen, and we don't know whether it's going to improve and what's being done apart from regulations being there, and who's implementing it, who's exposing, who's working on sanctioning the polluters. And I think we have a lot of open questions to discuss maybe some other time. But I was also wondering, since you are an innovation specialist, do you think there is still a space for a business model for some startups to get involved in this area, or is this field completely covered now by foreign companies?
I mean, again, it's not like exactly my domain of expertise, but I mean, every data set could, in theory, be monetized. I think that these data sets, which go in the direction of like air quality and similar, I mean, there should be, in a way, like a digital public good, almost, like something which is accessible to everybody, and that everybody should be able to build on top of this data some kind of a product. So maybe I, as a consumer, I would maybe pay for like a better user experience, and that in theory could be like the monetization of like a smart startup that could leverage that. But I think that there's always space, but that opens the question of accuracy of data, availability of data, geographical coverage. So also, like, it's much easier to monetize data for more developed markets, especially for when doing some kind of market research. I'm not sure that our local market is there yet. I'm pretty sure it's not. But on a global scale, probably yes. I think that more and more decisions are being data-driven, and more and more informations or like decisions are being made by using indirect data. Like there's like a interesting story, like how people in Negrin Coast were assessing the number of tourists, like in I don't know, 70s, 80s. Could you just imagine, like you're like a person who does statistics, and
number of hotel nights.
Yeah, but I mean, how would you get that? Like you need to go to each hotel, and and there's like a lot of people doing the private accommodation, like it's like the communist time. So I mean, people were eventually like going to bakeries and getting the number of breads which were made every day. So based on the number of breads, like they were assessing the obviously it's not like exact number, but that's like a good enough value. So I think that using environmental or any other kind of data for like indirect assessment, like of different parameters, is like a very strong thing to do. And I think that environmental data have its role in this, but it's a question how when.
Yes, so I think Elizabeth already answered the importance of why is the quality of air important in terms of health issues, and you've covered why is it important to get involved as an individual in these measurements, also for your child's health, not just your own. And we're still lacking measurements in some parts of the country, so we're not there yet. And as well as our network is doing the best with this workshop here to at least ship another 30 Climercos in good hands of citizens that will install them and add on to the measurements. I'm also wondering, we already heard from Professor Đurđević how he uses satellite data for climate predictions for Serbia. But I wonder whether there is anything, do you see any patterns from 2023 and 2024? We don't have the data yet, but between 2022 and 2023, whether the pollution's is becoming worse, or is it, what is the?
Yeah, but I'm not sure about the pollution. I think that it's more or less the same level. If there is any kind of changes, I think the changes is within that statistical uncertainty of measurement. So I'm not sure that we are on the point that we can say that we see some kind of path that is taking us out from that red zone of bad air. Okay, so the last thing that I checked was the sulfur dioxide emissions from Serbia, measuring from satellites, because it's hard to get this kind of measurement from thermal power plants in Serbia, but NASA can get it from the satellite, so we don't need this thermal power plants operators. You just need to know the website from which you're gonna get the data, and they have data from 2012 up to 2023. And it is true that
is it an open NASA data that we can go and download?
Yeah, it's a website which is used to monitor the volcano eruptions, because before volcano erupts, it emits a lot of sulfur dioxide. So they use that site for volcanoes, but our thermal power plants are so big emitters in sulfur dioxide. They can also monitor our TPPs. So I've been there, and from 2012 to 2023, the total sulfur emission in Serbia, it's more or less the same. You can see that Kostolac emit less sulfur dioxide because they put this desulfurization system, but we have some kind of additional power there. So they put in one, but they build new, and that new is additional emissions. So when you make a sum for the whole Serbia, Kostolac and Obrenovac, the number is same. And if we really want to see this, as I said, this kind of constant decrease in pollution in Serbia, which is significant, I think that first of all, we should see this decrease in sulfur emissions, because it's something which is seen in Europe when Europe starts to improve air quality. Because if you check European laws and analysis on air quality improvement, you will see that the major thing was decrease in sulfur emissions in European Union. It's very clear message that things is going better when you see that this SO2 curve going down. And in Europe currently, the SO2 emissions is like reduced by 90% there. Okay.
And this is due to technology, doing special filters and investment that needs to come. So going back to Vučkovac, I wonder whether you can tell us a little bit about these tools that you as librarian use, that the citizens who want to be part of citizen science movement that you mentioned could actually access on the Institute of Nuclear Sciences.
Yes, but it is not really available for citizens because the tools that we are currently using are meant for researchers. And but they are developed on open infrastructure or on open source. Sorry, infrastructure is DSpace especially for my library, but and for others that it is done by Computer Center of University of Belgrade, and some other use universities use other platforms like ePrints, and there is also Fedora and many others, which are openly and freely available and under open source, and it can be used by others. But especially what are we doing in my library and in other libraries that are connected in our community is we are trying to educate our researchers to do better research data management, which is, we want, it is like something that has to be done before you open the data sets to everybody. That data sets should be cleaned and should be made in such a way that it can be machine interoperable. And that is now set by the guiding principles, which are called FAIR data. I don't know if you FAIR principles. Yeah, you heard
We
it.
had
Yeah.
a presentation
Yeah,
yesterday
yes.
on FAIR
Okay.
data, and
Yes,
there's
good.
actually a flyer here on AI FAIR data
Okay.
principles, which we'll present later on.
Yes, great. And also, FAIR principles are not just done in data now. Data sets, it is now available for software and for hardware and infrastructure, and it is more and more the common principle in the whole science now. Especially European Union is pushing that really hard, because that is like a basic for the science later on. If it can be, the data sets and the software and everything could be measured in such a way to be machine interoperable, it is going to be more usable, but more reusable, especially by the citizen side. One other thing also to consider is that and that is the project I mentioned that university library is doing right now. They are one of the key partners in that European project. And it is called CEOS, but I don't know the full name. But it is meant for enhancing citizen science among higher education institutions in Southeastern Europe. And they recognize us as a kind of weak spot with citizen science. And there actually the university library is doing the task of educating higher education institutions and research institutions how to come to the citizens, how to come to the public, and how to engage with them in science. And they are doing some, I would say, educations on that, and they are
Some capacity building.
Yes,
Hopefully
yes.
we can help you as well bridge this gap, how to get to the public and
Yes,
community.
yes. We are not. I mean, Venture is not involved in that project, but University Library is, and they're doing that quite good. And we usually we recognize that as the main problem here. I mean, there are kind of a huge gap between people who, like Vladimir, are using and understand the data, and researchers that understand what they are doing, and the public, and mostly public that doesn't understand. There is a huge gap, and that gap is rising from every year. And so if we want to include public, not just to engage in science, but to understand science, and not to trust, especially newspapers. And for that, that's going to be a huge task, monumental task, and that is something that, especially we as librarians, recognize that would be that could be a point that where we could, join in and help as much as we can.
Would the citizens, volunteers be able to help you there? Is there a place to connect and get involved?
Yeah, currently University Library is with this project. They are trying to engage with other libraries in a way to show them the possibilities of how to engage citizens. But this is the project that is just started, I think last year started, and it will last until, it's 3 years project, it will last until 2025. We will see. I was on one of their workshops, and I can say it was very helpful. And but we will see. It is usually meant for not just for research libraries, but usually for public libraries, as they are in many, especially small towns in Serbia, they are usually the main and sometimes the only place where citizens can engage in some cultural activities, but also with some scientific activities. They recognize them as one of the main partners. And concerning research libraries, where I work, we are usually, we usually look for researchers and how to educate them to, like I said, to do more open science, to provide more open data and open software and that kind of things. And but citizen science, yes, that is one of our next agenda. But we will see. We just lack human capacity. I mean, we lack of more skillful librarians, especially who can do that and who will do that. And we are actually lack librarians in our research libraries, unfortunately.
So we identify many lackings there, lackings of measurement of data, trained librarians, and some positive things as the sulfur dioxide going down in the area. But I will open it up for questions, I think, to the audience as well, for our panelists to. So we only have 2 mics here, and we'll pass one.
Thank you very much for your very inspirative inputs. I have a general question concerning citizen science. Would you say there is enough? Would you say that citizen science would be possible, and if so, in how far, in any of your disciplinary fields? And would it even be something that one should wish for? That is my first question, and depending on the answer, I may ask the second one.
I think maybe you can have a second question.
Maybe later.
Maybe later. We'll take a few more questions and.
Yeah, I mean, I was just listening fresh, not in any way. It's been really impressive what you're all doing. I guess the question that's begged by the comments is there a potential for working with schools? Because it seems to me we're all talking about children, talking about public, talking about next generation. Is there scope for an intervention within the classroom curriculum, and how might you go about, or who would go about exploring
that? We'll take one more question. Maybe, yes, one more question, and then we'll decide who wants to have a go at each one.
Thanks. So I guess my major concern and question is, why would any government be so terrified of citizens having access to so much data about what can actually impact their own lives? I mean, this has been the biggest conundrum and puzzle for me for the past many years. So, and I'm still I haven't really, I mean, reached any reasonable conclusion about this. So I don't know if you can share some of your thoughts. Why would governments be so closed having citizens access publicly open information, which is important for them to have control and have kind of take responsibility for their own lives and make some choices based on open access data. Thank you.
Thank you. As I was working, in fact, on this, as we call science policy interface, that's it, use of scientific data for developing policies and who should be involved in this. It's also, for me, unknown. It is a fact. Why? I mean, it is a fact that in many countries, it is also linked with the political past. I would say I worked in 53 countries of WHO European region. And in the countries of the former Eastern Bloc, is such an attitude more or less, depending if they're now European Union, implementing some laws and so on. But from the practice, from the practical opinion, it was much bigger headache afterwards for the same politicians and governments if they were hiding the data. And that's the rule. I wouldn't recommend anyone because it's coming back as a boomerang, really. And this is the reason. And in fact, developed European countries, old EU, went through this process during the 90s years of the 20th century, and citizens on the streets and requesting data. And as the result, there is a so-called ESPO convention on environmental risk assessment and strategic risk assessment, which requires these assessments, including health risk assessments of the new projects, new plans, and requires involvement of the citizens from the very beginning of the process. In the eastern part, these are UNEC conventions, so in fact all European countries should implement them, and we are also the party, and we have the laws that are very much aligned with this, but we have the situation that this public debate is really like formality. No one really involves the citizens, and for the citizens to be equipped for the public debate, it is really important that they have the access to this data. So this is connected. They don't have the access, sometimes even experts don't have the access to the data, and it's a kind of a fight. But I would say that it always comes back, and we see what is going on now with this lithium project in Jadar. Because from the very beginning, when this spatial planning with strategic environmental impact assessment study for public debate was developed in 2019, no one knew that it was public debate. No one heard these few people who had some remarks. You can go online and see the remarks. There were some Serbian citizens of Serbian origin from US, from UK, who are educated, who had really, I mean, smart questions, because obviously they work on, they are more experienced. But that was put like that, and then we have citizens on the streets. And now we are continuing the same way. I would say I wouldn't recommend any politician to hide this data. I mean, there is a main reason: it is not ethical. As a medical doctor, I would, first of all, it's not ethical. Secondly, it's against the law. Thirdly, it's against also Serbian constitution. But they still do that.
Thank you, Elizabeth. We had also a question here about how do we get involved with schools, and I could only make a comment that the Internet Society Serbia Belgrade chapter had a project with 36 schools 2 years ago, where we installed for STEM education some 135 measuring air monitoring Climerco Pro. They were installed measuring not just the PM particles, the levels of those, but also looked at NO2 and SO2. and kids were and parents were really exposed to something new then, because when you start caring for your kids, you start caring for yourself as well. But this project is still ongoing. It's called the Children for the Air, Deca za vazduh, .rs. However, the main supporters, UNICEF Serbia and Norwegian Embassy, have not continued funding it. So it's now a question of who's going to continue funding this project, and that's an open question. So for reminding us. If I think we have no more questions online, but maybe just if we try to end up on a more positive note, I will give everyone from that end some wishful thinking for 2025. Where could we be where we are today?
Okay, good news. Okay. Yes, considering this open data and everything, we have a national policy concerning research results that is from 2018. It is called Platforma za otvorenu nauku, or it is a national policy, a platform for open science, and where all the research articles that are published and funded, all the research that was funded by the national funds, ministry, and now Science Fund of Serbia, all the research should be publicly available. But that means all the research results, like research articles, books, and that was the first iteration, and now we are working on update of that policy, and we hope that it will be done by the end of this year, and it should include open data as well, and open infrastructure, and open software, and so on.
What kind of data would you find on that platform? If it
It is not a platform not in that sense, like some software or internet, but it is a document. It's a national policy, just a document that states that all the research that is publicly funded by the government money, partly or in full or in partial, should be publicly available. For some things, it's probably going to be for I don't know, open hardware, or probably some other things. It's going to be just a recommendation, not going to be
legislation.
Yes, it's going to be just
soft law.
Yes, and for citizen science, I think we didn't include it, but it will probably be in some other, because open science is very dynamic. It's changing a lot, and since 2018, in that time, that was kind of we catch up Europe, and we were aligned with the European. And at that time, in 2018, we were one of the few European countries that had national policy. That's very interesting. I think in terms of open science, we are pretty advanced. Yeah, we're pretty much near the Europe. But like I said, it is a dynamic field. It is changing a lot. There are more and more requests. And for now, we are trying to catch up. And I think with this new national policy, we will eventually catch up. For now, that's a good, positive thing.
Yes, I had a little question. Again, I know Serbia is not part of European Open Science Cloud, but are there any plans on building the research data infrastructure, national research data infrastructure, that would become part of the
Okay. I'm not that expert on European Open Science Cloud or EOSC, but we are part. I think Institute of Physics, it's part of University of Belgrade, is the member of EOSC Association, or EOSC EOSC Association, I think, yes. And I think yes, and I think computer center of University of Belgrade is also active, but I don't know in what capacity. And but EOSC is not designed to be one infrastructure that is going from Serbia or from Germany, from any other country. It is meant to be as a hub of all the services and other centers or something like that that are going to provide in some mutual way something that whether it's going to be research services or data or articles or whatever, that is going to be aligned on some common consensus and to go back to that imaginary cloud. But I think EOSC is now on some kind of crossroad. I think that they are now planning on which way to go for the next phase, I think from the next year.
Thank you. Maybe Elizabeth, if you wish to comment, especially since we have in UN now the Climate Week in a couple of weeks' time. Do you expect any big news from New York and the UN General Assembly?
I can only say that the last year was the year, for the first time year, where the health arguments, and Professor Đurđević knows that it sounds really silly. But for the first time, after 30 years of negotiations, health arguments have been taken into account as why should we stop global warming. And it seems that this is continuing this year. So these are good news from my end. And I would also comment some other good news that are also accessible for the citizens. For example, to come back to the air quality impacts on health, there is a completely free of charge accessible software of WHO called the Air Quality Plus tool. And if all the data of air quality data are available, and also health statistics data are available, and they are, it could be in fact used, and anyone can in fact apply it for its population, from the municipalities to the country level. But for the country level, we have health impact data because there are governmental papers that are mentioning some impacts. There is European Environmental Agency who is doing that on our behalf, and so on. But this is also, I would say, a lot of private persons is also not only researchers at scientific institutions, but private persons is using this software worldwide.
Thank you.
So, on a positive note, I think that the good thing is that I think at the local level in Serbia, nobody is anymore like saying that there's like the air quality is not a problem. Like nobody is denying the existence of air pollution. And I think that happened because of data is now available, and the topic of that has somehow found its way to people. And through projects like Limerco and similar initiatives, like this is started to be a part of a first step, which is required in order to solve the problem. Like when you acknowledge that there is an issue, that's a starting point. How and when it will be solved, and can it be really solved on a local level, that's a completely different topic. But I think that we are past the point that anyone can, deny that there's an issue. So that's good, I think, and I think that what I also find very, very positive is that I think that people are generally very interested to be a part of citizen science initiatives. I think that like the amount of interest that I saw, there was I think that there was like a short TV article for BBC Serbia, which interviewed Limerco. Like the number of people which reached out, like who bothered enough to find my name because I was a vet in that video article, to find me on Facebook and to send me a message asking, like, can I also build one of these, or can I buy one of these? I mean, that was pretty amazing. So I think that people are interested, and I think that we are lacking enough opportunities to actually, like, give people who want to somehow get involved or like to understand more about that topic through actually being involved. I think that these opportunities are lacking, and that's something that probably research institutions should be like blame, but like should be accountable for, because many issues not only related to climate can be sort of mapped or identified by using citizens and their devices as a tool to actually gather pretty good research data. So that's something that I think that should take more like visibility. And I also find it on a positive note that more and more governmental institutions are really complying with open data requirements. And I sort of hope that this will continue, that it will not only be because they got money to like implement open data platform and to open some kind of like old data, but that it will sort of start to be a usual practice, like what you do when you as a governmental institution have data. We are not anywhere near that, unfortunately, but at least in some ministries, like some, you would say, non-crucial ministries, you see people or initiatives who are like putting data online, and that's pretty important in the long run.
Something positive. For climate, it's really hard to find something positive. I'm sorry.
Excuse you.
I'm sorry. We only have this bad scenario and super bad scenario, so you can choose between two.
So let's skip that and talk over the drinks.
Yeah.
I think and think of some solutions. So
I would like just to say that I think that we talked about many topics, etc. But I think that one of the things that we should stick on ourselves is try to promote the concept of open data as a concept, as it is, because I'm not sure that people really understand what open data means and what are the benefits of the open data, etc. So I think that we as a group and the people who discuss this and that, we should probably try to promote the concept itself, not just data, just to people to understand that there is a lot of data who can be easily accessed, read by machines, processed and present. That is very important to one society to have capabilities to do this kind of stuff, to process a lot of data, to present it in an easily understandable way, to make decisions about the data, etc. So I think that it's really important. And that's the reason I think also this conference and also the things that Open Society of Serbia is doing is very important, just to promote the idea, because you have data is just one thing, another thing is science, then you have this open hardware problem. We heard something about that before with this IoTs, because it's problem of open hardware. When you buy something, you want to know what is inside, how it's programmed, what is the capability of that, etc. So there is a many open things that we need, that maybe open data is good to be the main point of promoting the openness
of the internet, and the minimum sharing and downloading. I'd like to invite everyone to give a huge round of applause for our panelists and thank them. So thank you so much. And, with that, we will be back here at 6 p.m. local time for the reports from hackathons and workshops and the awards. See you then. Hey, so welcome to the final fun part of Descon 8.0. We will first hear the presentations from the hackathon team that worked on the Climerco enhancing features. So I would like to invite team of Žarko and Novak to come and present their solution. The floor is yours.
Hello, my name is Novak Stjepić, and we are going to be presenting our solution to the Klimerko improvement competition, which is called Mobile Klimerko. This is a step towards bigger Klimerko coverage across Serbia, and that is something that we look forward to because our end goal is to have perhaps a map of more polluted and less polluted areas across the cities of Serbia. And we also enable other people with this innovation to be able to walk around with their Klimerkos, or for example, be in vehicles like bikes, and measure real-time pollution data at their exact location. You can see here a map of London's most polluted areas. So this was made in a really similar fashion by measuring really just over a lot of time and a lot of locations the current pollution data. And this is something that we have taken as inspiration to do with the Klimerko device as well. So, Žarko, will you explain how we made it?
What did we actually do? For avoiding additional costs and buying additional sensor for the Klimerko devices, we wanted to already use the existing hardware that we have on hand. So we wanted to use our phones' GPS capabilities to send the location to the Klimerko device and to, on that way, gain an interface for the location data. So we made a simple app which takes the GPS from the phone, sends it to the Klimerko device. The Klimerko device processes that request, and it updates its location in real time. It sends it to the server, the new location. We also changed the firmware. It was mostly what we changed. So we haven't made a lot of hardware changes in the project, mostly software applications. And we send the measurement data more often. And we have a server listening for the location data from your phone. And as soon as you send the location from your phone, it updates the location on the Klimerko network. So yeah, all the steps needed to do this is just install the mobile Klimerko app, connect it to the Klimerko device, and that's it. You basically have the whole thing done. You now have a Klimerko which has mobile location accessibility. Here is something that we plan on doing more because we haven't had enough time on the hackathon to make the most of our ideas, but we have a lot more. So here's something that we haven't planned.
Yeah, we really had a lot of ideas. So of course, the first thing that I said is it would be nice to, on the server, to have a visualization of historical data in the form of a map. I will later show a demonstration that I made doing that, but that's something that I think would really benefit the people of Serbia to know where the air is more polluted and where it is less polluted, especially in larger cities where probably more people will use their Klimerkos to measure it in different locations and in a lot of locations across the city. The other thing we could do is, so you heard that one of our goals is to be able to ride it on a bike, for example, like to place a Klimerko on the bike or in a car or something like that. And we do need to test wind impact on Klimerkos to do that in open space. So because it could perhaps impact the data produced by the sensors. Yep. We should also publish the mobile Klimerko app and to make it readily available for everyone who wants to use the mobile Klimerko. And another idea we could do is to make it easier to access the real-time sensor data to the user of the mobile Klimerko by having colored LEDs on the Klimerko. It could show pollution levels at your exact location in real time. So this is a map that I made using fabricated data. We haven't had the chance to go around the city during the duration of this hackathon to actually measure levels across Belgrade. But this is something that is a demonstration. So as you can see, as you already know, sometimes sensor data isn't ideal, and I actually made sure to add sensor data which is not which is statistically an outlier, and we can still see that the map is usable. So obviously on the right hand side we can see that the pollution levels measured are lower, and on the left side the pollution levels are higher. We used inverse distance weighing for this because it is a simple model, but of course it can be improved. Also, another thing which should be done if we were to do this is using scaling the measured data in proportion to the average in the city that is recorded at the current time. So, for example, if pollution levels across the entire city are low at the date that a value is measured, we can scale it. We can make it larger or lower in order to show how this location is relative to the average location in the city, because that's exactly what we wanted to measure.
Yeah. Here we have an example. This is actually the location that you see on screen. These coordinates are actually the coordinates of the impact hub, which we are right now. We've sent the data from our phone to the Klimerko device, and the Klimerko device reported its location to be our location as of right now. So to test it a little more, because we didn't really have time to move with all the hardware and go around and see how it would work, we made a mock on the phone. We mocked a fake GPS location and sent Klimerko halfway across the globe to see it on the map, to see it change. So yeah, that's something that you can see right there. And here's an idea about how an app we wish to make would look, something about it. You could see the measurements, and you could also see the measurements from your own Klimerko. And another big thing is adding the location and time data, so that when you are in one spot, if you change the location of a Klimerko device now, it disappears from the previous location. All the measurements transfer to location as of right now. And we would like the measurements before to stay on those points. So you could take a Klimerko device, attach it to a bicycle, said, and go across the city, and you could have a bunch of different points on a map which indicate air pollution levels on different spots in the city. So yeah, if you have any questions, feel free to ask. Yeah, and we want to thank our teammate Despot, which unfortunately couldn't make it here today, but he also worked with us yesterday, and he is a big part of our team, a very responsible member. Questions? No. We are using the GPS from the phone to send it to the Klimerko. So the Klimerko doesn't have GPS capabilities yet, but we've thought about a few another few things. As using the Klimerko device, there are a few different ways in which you can pinpoint your location. One method that we really wanted to use was to scan all the networks nearby, send it to a Google API, and get the location that way. So that way the Klimerko device would be standalone from the phone. It could get its location anywhere, and all the Klimerko devices in Serbia could pinpoint their location that way.
Great. And would you have a different kind of color for the mobile Klimerkos on klimerko.org map, or how do you see that?
I mean, the mobile Klimerko data would mostly be used for aggregating historical data. But if we were to make a live feed, like to be visible on the map, as we actually made, yeah, we made it, to be visible on the map, then it would be visible as a regular Klimerko, because as you maybe saw that the values measured were pretty much the same as the areas around us right now. So that is a valid measurement, and this is the same measurement as the regular Klimerko.
Congratulations. I think you win the first prize of the Enhancement Klimerko Hackathon. So there's a small Raspberry Pi.
Thank you.
Thank you. And also for Despot and you. And we hope to stay in touch of how it progress. And so I hope we'll continue working on it. Great. Thank you. Good fact. Unless there are any more questions. No. Good. Next on the stage would be the results of the, thank you again. And for everyone, there are t-shirts downstairs and also Descon bags or toti. So please do not leave the building without one. So yes, the next one is the, if I may just call to the stage Jovan, to the captain of the capture of the flag competition, to announce the teams.
So first of all, some statistics. So we had around 20 people or teams. I don't know if teams registered as one user, play this CTF, and we have one definitive winner. But before announcing winner, let's go to the third and second place. The third place is user called Okraz. Oh, nice. So he managed to do it even with both competitions. Nice. I mean, congratulations. Then the next one is points. Yeah. So points is 6,048 points. So the second place is DISM4L. I don't know how to pronounce it. Is he present here? Maybe. Her? Not. Online, I guess. Maybe. And the first place is with someone with username Z. Is he also here? Guess not. So we have our winner. So I'm not sure about what is the maximum, but the first place was 12,000 points. The second place was 6,900 points. Yes.
We'd like to congratulate Zed Steva, the first winner. He will get another award and a bottle of Žuta Osa, which is a typical Serbian brandy made of quince. Congratulate you on multitasking and doing 2 hackathons at one. We wonder why you ran out of time. And the second team is, what is their name? DISM4L. If they can contact info@descon.me team to send up their awards, and we'll be in touch with you. So well done, 7 teams. Congratulations, Zed Steva. And again, I think he's a member of a Hack Club Belgrade. It's nice to see you join us. Great, thank you. Sorry, your awards. The next on our agenda is to actually hear from Larissa, the designer who brought us these zines. If you remember, we had an interesting time folding them, at least. And there is a few websites where you can find more information about fair AI data. And maybe you would like to say a few words, and thank you for bringing them. It was a lot of fun.
Well, thanks, and I'm not going to keep you long. So I just want to explain why I brought these and what these are. So these started off as a project where they wanted to define or explain the metrics behind the fairness metrics that exist around AI and how they work and if they are of any help to create a better or fairer AI. So they created 4 posters, and then in order to make these posters handy and explainable, they made these 4 little cute scenes where I assisted them making them. So I don't want to take the credits. So in order, these scenes, they are under CC BY license, so you're welcome to share them and read them. You can find the license and the authorship here on the zines. So whenever you want to do that, it's enough to name the authors. There is a German and an English version. I'm happy to add the Serbian version if anybody is up to translating those. They're fresh off the press. So currently, the website where they will be made available is not online yet. But so either you keep on checking the website of that institute that is named here as a copyright, because it's been a research effort, or I can also share the file through Desiree with the community. So happy to. I've been asked whether they can be used in schools or whatever. Very happily. So the first one explains a little bit more like how does an AI work? What is an AI process in order to understand it for audiences that are not aware of what AI, how does that work? The second one explains a little bit where does the biases enter in this whole process and where do biases, I think we had that question earlier today. So that would be the zine to contact. And then the third one explains exactly how do these mathematical fairness metrics work in relatively simple words. And then the fourth one debates whether solving it on a mathematical, like sort of systemic level is the right idea, or whether we should actually take another approach and create more fairer, better AI data sets in particular. So happy exploring, and they're all over the place, and otherwise you find them online, and you can print them and fold them and cut them. It's
Last but not least, we had many workshops. Climerico workshop was a success. Many were assembled together, and the last one is about minimum data sets or minimum sustainable data sets. And I'd like to ask some of the members of the workshop to come up and present their thinking. I think it's a work in progress, so maybe you want to bring it up on stage. I know we are here between music and beer and drinks, but hopefully, yeah, any member of the team who would like to say a few words about the complexity of trying to think what minimal data manifesto should be. As far as I understand it, the brain.
The brain and mind. So yeah, it has even another layer of meaning. So we did agree that it's not that we agreed that we disagree on anything, but it was well, first of all, it was very inspiring. It is work in progress, definitely work in progress. And what I will not tell you what's written here. You can later on you can drop by and look at it. What we actually agreed upon is that it would make sense to call different communities that are interested in working with data to define what they would understand under the smallest possible data set that would be useful for them, right? So you can expect as one of, I believe it will be a call by ISOC or ISOC Chapter Serbia to participate in online workshops or online events where people would actually not only reflect but also try to define what are the conditions of the smallest possible data set that makes sense for their own research and for their own computing power that they have. And we hope in the future it would make sense both for citizen science, but also for people doing investigative journalism or for people doing any kind of artistic research, right? So for very vast areas where data analysis takes place. So that is basically the very idea. Please expect a call for participation and for common reflecting. Thank you.
And there should be some entry on Wikipedia in Serbia where to deposit their thinking or something.
We will talk about it.
Thank you so much.
And one more thing, sorry. If you are interested to learn more about what's written here and what we were actually noting here, please feel free to approach me, Larissa, or Roma, and we will be happy to to share more about it. Thank you.
Thank you, Jan. Very nice of you. And I think for the workshop members, they all get a copy of this book, which I also recommend to other people. It's about, digitizing. Where is digitization taking us to, and what are the answers? And it contains a lot of valuable answers. Smart Green World by Stefan Lang and Tilman Senatarius. With that, let's go and join Sergio Lounge downstairs for some beats. And thank you so much for contributing to Descon 2.0. I had a wonderful time. Hope you did as well. And DJ Oliver, Beast Boy, will follow up Sergio Lounge, so you can also boogie